What's up, everybody? Happy Tuesday. Welcome to the channel. Day 2 of tracks. It's good to see you all here. What's up, silly boo boy, Propagation Nation? How's everyone doing? Sorry, I got a little caught up again. I was trying to, use this Garuda Linux thing, this distro. I really wanted to check it out. So I was going through the setup of it to kind of see how it works. Garuda Linux Hot Eagle rolling release. I'll close this, but I hope everyone's doing great today. Welcome to day 2, where we're gonna dive deeper into the world of Git. Let's down a little bit. Deeper into the world of Git, learning about what it can do, how we can use it to work together on a team. Yeah, it should be pretty exciting. Today, we're gonna dive into a couple different things. We're gonna talk about HTTPS and SSH and learn how to authenticate in different ways. We'll also talk about the GitHub CLI. That's not listed on the thing, but I will talk about the GitHub CLI as well. We will dive deeper into forking and understanding how to contribute to open source and how to get set up with multiple keys. We'll dive more into the workflow, understand how we can find out more information about what's going on, how our code has changed, all that stuff today. And yeah, so this theme, I didn't make any of this. This is a default installation of Garuda Linux. Garuda is an Arch-based distribution. It's a new kid on the block, or at least as far as I'm concerned, it's a new kid on the block. I've never heard of it before. It has a pretty in-depth installer. I actually want to go back and go through it again to kind of see. I kind of clicked through things because I didn't really need it for this. But this is very interesting. This is a very interesting and also promising distribution. It's kind of impressive. So I'm not gonna lie, I think I like it, but I want to dive into it. This theme, I don't know if these are custom Garuda icons or there's something that were chosen directly from something like GNOME Look, but I like them. This wallpaper though, if you all go back and look at my videos from 2 years ago, I had the same wallpaper. The first person I saw with this wallpaper was MKBHD. This was one of his old school original wallpapers that everyone loved. And I'm not gonna lie, I always keep it on my computer, and it gets used a lot. There's not many better wallpapers than this. It's a really good wallpaper, at least in my opinion. But it's a pretty dope theme. I really like this. I kind of need to click around to see what the rest of this looks like. You even have a themed terminal out of the box, which is really nice. Wow, this is actually pretty impressive. Let me just check out some things really quick because I have no idea how this is set up. Ooh, it uses fish by default. Very interesting. Well, check that out. What's up, guys? I've been using this wallpaper for a couple weeks now. 100%, always gonna have it early. And people are just getting onto it. Now it's an official distribution wallpaper. Interesting. Uses fish out of the box. All right, cool. We might use that. Well, okay, it's up. I'll get out of here for now. We can hop back into this a little bit later. I just wanted to finish the setup. Fish is another shell terminal emulator, another shell, just like Bash or ZSH. But yeah, it's based on Arch. Yep, Captain Tidbit. It is an Arch-based distribution. What kind of computer am I on? What you're looking at right now is actually a Surface Pro. It's actually a Microsoft Surface Pro, only because I want pen support, so I can draw cool pictures for you if I need to draw cool pictures for you. Because of the aspect ratio. Both of those reasons are why we are using a Surface Pro, but this is being streamed through a much more powerful computer, a custom build that I have. But yeah, this is just a Surface Pro for this. That was what you were looking at, was VirtualBox. So I was just virtualizing that. But yeah, Windows updates going on, all good. So this is my normal Windows desktop. We did some Pokemon stuff, and so we got some Pokemon stuff up there. But go ahead and hit ! Slides to get the slides for today, and then we'll get started and go through what we got. Let me grab this, take it. It's a good question. I do prefer VirtualBox, but I don't prefer VirtualBox for any specific reasons other than it is what I'm used to. I've done some Hyper-V emulation as well. Great. I just don't have much of a need for emulation or virtualization anymore, to be 100% honest. And Hyper-V, I'm sure, is fine. I just haven't used it that much. You saw Linux on Surface Pro. I'm considering it. If I can be confident that I can get pin support, I will do it. What's up, do this? Good to see you. I'm good, cannot complain at all. Just ready to dive into day 2 of tracks, learn a little bit more about Git. Oh, and you have pin support? Did you use the guy? I know I found a repo on GitHub that kind of goes through all that. Which Surface Pro did you install it on? I know some of them are more compatible than others. And did you use the guide on GitHub? Or not guide. I think they have a compiled kernel that has the updates and things that you need on GitHub. I think that's what I found. I'll definitely try it out. Ooh, it just got warm in here. Okay. So day 2, we are going to be covering a couple of different things. We're going to dive into SSH versus HTTPS versus, because this is the newcomer, GitHub CLI, and we'll talk about those things. These are going to be your methods of authenticating with GitHub. How do you tell GitHub? How do you show GitHub who you are? And how do you know what you have access to? How do you gain access to be able to push things and pull things? We'll talk about those. It's good to understand that. We'll talk about SSH key management because it is good to know. Even though now that the GitHub CLI is a thing, I think SSH keys are going to become possibly become a little less important. Maybe. I guess it depends on. We'll see in a second. Tracking changes and comparing them. So that's the whole thing Git wants to do. About how do we follow along? How do we understand what Git sees? How do we know where there's differences? How do we know what's going on? How can we see what the history of this thing was? Fetching and pulling, we'll talk a little bit more about the intricacies between them and how you get things. Pull requests, very, very important topic in Git. We'll talk about pull requests to help you understand those things. Merging, probably the scariest thing and the biggest thing that we're going to talk about tonight. And there should be, are the slides not in here, or did I just not put it on this page? I think we're also going to talk about, contributing to open source. Yeah, contributing to open source and forking. Forking, contributing to open source are going to be the last 2 pieces that we're going to talk about tonight. So a number of things. Let's put this here so we can go forking, and we'll talk about open source. Cool. There we go. I have a Surface Pro 4, top of the line, everything. Okay, I'm definitely going to try it out for sure. I'll definitely try it out. Yeah, Miss Green. Hey, sometimes you gotta cuss out your teacher. I get it. All right, yes, Git diff time, 100%. Git diff is great, and we're gonna learn a little bit about it. So let's get started. First, SSH versus HTTPS, the age-old question of what we need to do. And yes, Dracnet, Git is absolutely a must-know for a software developer nowadays. It's an absolute must-know. It is one of the most important technologies to software development. You need to know it. So these 2 protocols. One, all the protocol is it's a set of instructions for in this case for communication. That's all a protocol is. It's a set of instructions to follow to make sure something happens. All right. So these 2 protocols have been the things that you would use to communicate with GitHub and to be able to authenticate. Tell GitHub that say I am who I say I am, and authorize. Which once GitHub knows who I am, what do I have access to do is the authorization part of this. This is what we use to gain access to GitHub previously to the GitHub CLI, but even still with the GitHub CLI. But these were the main 2 forms of things. So HTTPS, just to give you a little more information about it, stands for Hypertext Transfer Protocol Secure. So you've probably seen this at the beginning of a URL, and Chrome won't show it to you, but if you go to something like Google and you see the little lock here, but if you click over to the side, you see that it has HTTPS : / That is the protocol it is utilizing whenever you access anything in your web browser. By default, it is utilizing HTTP or HTTPS protocols to transfer information over the web. And so, when we're interacting with GitHub, we often use the same thing. All right. So HTTP is just the non-secure version. So yeah, HTTPS:// it runs over port 4043. That's not incredibly important right now to know, but just something to add to your tech tool bag, that HTTPS runs over port 443 by default. Data that's transferred between the server and the client, so the thing that's making the request and the server that's serving up the content, it's encrypted. This is why it's secure. Okay, the data that's transferred in between it is encrypted, so it's jumbled up. It's jumbled up and on one end, and then it gets to the other place, and the other place says, hey, I know how to decode this jumbled up message, and then it is decoded on the other side. That makes it more secure. And encryption is enabled via something called an SSL or TLS certificate. SSL is actually not a thing anymore. I should probably remove that from this, but it's still a common, people still use this, like the whole Kleenex thing. It is not a thing anymore. TLS certificates are what enable this, but there's these certificate files that you use to be able to get this little lock on a computer. It says connection is secure. It is using a TLS certificate to enable this, to enable that encryption between the connections. So GitHub has these certificates, and it is allowing you to encrypt the data in between, but it is allowing you to log in and authenticate via this. This is how we've been talking to GitHub. This is how we've been able to verify who we are with GitHub, through our login. And when we went to go push yesterday, every time we pushed code, it would say, hey, what's your username? And we type in our username and say, hey, what's your password? It is using that password auth over HTTPS. Okay. SSH, on the other hand, this is another protocol. This protocol is short for secure shell. All right, and this is the method. SSH is the method that Linux computers use to log into other Linux computers. So if you want to log into a remote Linux computer, you use secure shell, SSH. By default, it runs over port 22. And again, it is used to gain secure access to a shell on a remote machine. This is a common way of accessing systems. It is secure, and there's some obfuscation that's done here as well. But yeah, we could also use that to be able to interact with GitHub. But should we use SSH, there are other things that must be done. You cannot use username and password authentication while you're using SSH. Okay. SFTP also does use port 22 by default, because SFTP uses SSH as the protocol to do those transfers. But yeah, so those are two options that you have. And you might say, okay, so how do I choose some of these things? Let's log into GitHub really quick and let's take a look around. And so when we get in here, if you click around somewhere, I don't remember where this came from. This is from 2 months ago. I really don't remember what this is from, but okay. Oh, it's from Decoded. But whenever any repo, if you click on any repo in GitHub, if you just Google random GitHub repo, whatever you get to, the button that we used yesterday to clone our data and to be able to retrieve it, that we got from this green highlighted button here, it gives you some options. It says HTTPS, SSH is right here, and GitHub CLI. We're gonna talk about GitHub CLI shortly, but these actually present you with different URLs, and the different URLs or the URL strings are what enable you to access this via different protocols. And so you got to make sure you are set up to use the one that you want to use. So by default, like we've been using HTTPS, that's the one it gives you by default. But when we want to use SSH, we must clone it via this SSH command, or we have to end up setting our remotes up. We have to put in the right URL for our remote a little bit later, but that's just to show you how you would switch that up. Now, SSH authentication happens and in two different ways. There is password authentication for SSH. The protocol SSH does allow for password authentication, but that is not what works here. What you have to do to authenticate is SSH use something called SSH keys. All right, so we're talking about SSH keys. We're gonna hold off on the management of the keys for a second. We're gonna talk about GitHub CLI, and then we're gonna go back to the management of these keys. All right, so what in the world are these SSH keys that we're talking about? Well, they are a pair, so pair meaning two, of encryption keys used for authentication, but not only two keys, they are keys that go together, okay? It's a lock and a key, really. Public keys can be shared, private keys must be kept private. Pretty simple. So whenever you create these SSH keys, there will be a public key and there will be a private key. The public key you can use to share and to like put it on all the systems that you want to be able to authenticate with something else. And the private key must be kept private. You know, that's the lock, and it needs to be held somewhere. All right. So we're not going to talk about this multiple accounts thing yet, which it is important. I think it's something that you all should be familiar with. But before we talk about that, let's talk about the GitHub CLI. So we can authenticate with HTTPS, which is going to allow us to use our username and our password via the command line. That's great. It gets really annoying to have to type in your password every time. It gets, you don't want to, I mean, yes, it's fine, but I would advise against it. I think SSH keys are a good way to go. And so SSH keys are the other way, so we can access via SSH. But there's also something called GitHub CLI now. And this is very helpful to know about. Okay, so GitHub CLI is a tool that they've created that you can install right on your system. And it gives you basically all the functionality of GitHub right from your command line, which is incredibly, incredibly helpful. So if you go to cli.github.com, you can grab it if you need it. I am gonna get it installed. I'm gonna show you authentication with all three of these really quick, but you can get, I'm gonna get it installed really quick, and then we can keep moving from here. So it says download on Windows. I created a server for this, didn't I? Yeah, I created a server. So I'm gonna do that. I'm also gonna open up today. I'm gonna open up VS Code for you all as well, because I do want to show you. I want to, although we're going to be doing everything from the command line, I think it's important to also highlight the benefits of graphical interfaces or graphics that help you identify and understand what's happening through the Git process, because the Git process can actually be very confusing. All right, so we're gonna use that today. So first, let me grab my SSH command really quick, and I'm just gonna open up VS Code right here. I'm gonna log into my server via VS Code just so we're there and everything will be fine. Add new SSH host and put it in SSH config, and we'll connect. Continue. All right, what should be in there? Is the CLI bash base? Yes, it is. What's up, Aya? All good? Welcome. It's good to see you, man. Yes. So, Captain Tidbit, the way that you do that, there's an extension called, there's like an SSH extension. I forgot what it's called, but actually, you do this exclamation point. If you want to know how you can do exactly what I just did, exclamation point Linode, maybe. Yeah, if you click that Notion page, you don't have to use Linode for this, but it shows you number 3 says connect VS Code to VPS, and it shows you how to get the extension installed so that you can do exactly that. 3 more days for baby drop. Okay, so 3 days. What's that? The 19th. Okay, respect. The baby's gonna wait until Sunday. Sunday's my birthday. The baby's gonna wait till Sunday. Okay. I at this point, you wanna know how I know? Because 21 is a sacred number in this household, and I looked up why you said that, and it is 7/21 right now. Okay, so it's gonna be the 21st because it's special day. Like I said, my birthday is 3/21. My wife's birthday is 6/21. Her sister's birthday, we got family, 2/21, all the 1/21. So big number. The baby's coming on the 21st. I called it. What's up, AI Luna? Good to see you. All right, so now we're logged in. And so for now, I'll just open up a terminal just so we can do everything kind of right here, so that we can be where we want to be when we get started. So I'm going to cd into I'm gonna go into our amazing app really quick. And you don't need to follow along with this, just showing you the different authentication methods. Like I said, when I make a change, let's say I make a change to new file.txt, and you know, I just put some extra lines in here. All right, and I do a git status. So let's a little refresher. Let's go back over our command. So I do a git status so I know what's going on. All right, and it says, hey, modify new file.txt. There's some changes there. I'm actually on branch origin production. I'm on branch production. I'm not on main right now, so that's good to know. And so I might say, hey, I want to push there, so I do a git git add first. So git status, then git add. So I'm gonna add the file. Now that's staged. Let's check git status again. So we're good to go there. Everything's green. I think this is what I want. So I'm gonna add a commit message. Added new text. All right. So now that I've committed it, I've now changed the history. That is, I've done the work of Git now. I've changed the history there. I've made that commit. And now I'm just gonna do one more git status just to get comfortable doing it. And it says, hey, you're ahead of this. You need to push your changes. So then I'm gonna do a git push. And again, it's going to ask me, or at least it should have asked me. I guess it stores that session for a little while. Yeah, I guess it must have stored my session from the last time I authenticated, which is fine. But it'll likely ask you what your username and password is. You can confirm which methods you're using by this right here, HTTPS. See this link? The link here is HTTPS. Remember, there's different links for different URLs and different structures for the way that you're pushing. So currently, that's how we can push via that. Let's set up our SSH keys now. What's up, Helder? I appreciate it. Thank you so much for the kind words. Will do. All right, so now is where we're gonna get our hands dirty a little bit. We are now going to create SSH keys for our account before we move on to the GitHub CLI. So what I'm gonna do is go into your settings. So click your profile over here on the right, top right, and go down to settings, okay? And inside of your settings, you'll see a section on the left for SSH and GPG keys. Now, this is the process that we're gonna use to set up with GitHub. This will be the same process for all the other services as well. It might be located in a different place, but this functionality works with them all. And so I'm gonna click on SSH and GPG keys in here. Now, I shouldn't be, well, showing you the SHA is probably not the safest thing, but it's fine for now. And actually to delete many of these keys anyway while I'm in here. But here are some SSH keys. All right, it's okay. I'll just change them out. No big deal. And I have a bunch of keys for different systems that I can use to authenticate with GitHub. All right. You have two options for this. You have SSH and GPG. I don't know anyone who uses GPG keys for this. Don't worry about that right now. So in this screen, if you don't have any, that's fine. I want you to click on generating SSH keys or open it up in a new tab. This is a guide that tells you how to generate SSH keys. You should generate the SSH key from a computer that you are going to use to access, GitHub, okay? So I'm gonna do it from my server since that's where I am, but there's a pretty good guide here. It goes into, I do have one problem with this guide, is that it goes a little bit more in depth about some other things that I don't necessarily think that everyone needs, and it doesn't explain them well, especially when it gets into adding keys to the SSH agent and all that other stuff, but it's good. It's a useful doc for sure. So if you already have keys, you don't need to go through this part, obviously, but for everyone who doesn't, we're gonna generate brand new keys. So this is really nice. It's pretty easy to do. It's a one-step command. And so I'm gonna click on the option that says, that's gonna teach me how to generate a new SSH key. So it's the third option down. Go ahead and click on that. And here we go. So you're gonna open up your shell on your computer. And what you're gonna do is you're gonna copy and paste this command right here. So your computer, well, Linux comes with, even if you're on a Mac, this should be fine. Windows, make sure you're using Git Bash. If you're on Windows, make sure you're using that Git Bash terminal to make this happen. But it comes with a tool called SSH Keygen, which allows you to create these SSH keys, okay? Now, We're gonna take this, we're gonna copy it in, and we're gonna replace what's in here with our email address. All this is doing, it is generating a key with a certain hash algorithm, and yeah, and it's just gonna set that up for us. So we'll copy this, we'll take it, we'll paste it in over here. I'll paste it. Let me clear this out. I'll paste it right here. I'm gonna change this right here. It is okay if you don't put your email in here or you put the wrong email. It doesn't really matter actually. It actually just becomes an identifier. So it's okay. But we're gonna hit enter, and it's going to begin the process of creating this key. All right. So just paste it in, put your email address within the quotes, and let it, it's gonna begin asking you some questions. So the very first line right here says generating public private ED25519 key pair. Again, that's gonna be the hashing algorithm it's gonna use to be able to create these encryption keys, but it's gonna create two files for you. It says, hey, go ahead and enter the file in which you wanna save the key. So all it's really asking you is, it's saying, hey, I'm gonna save this file somewhere. Where would you like me to save it, and what would you like it to be called? My recommendation is, if you have no idea what this is, then you probably don't have any other keys, and by default you should let it be whatever is default. So by default it's going to set it up where it shows you this stuff in the parentheses. This is where it's going to set it up by default. I would leave it as that. Okay, so just hit enter. Okay, and so it might let you know that it created a new directory there. Great. It says, hey, enter a passphrase, empty for no passphrase. Do not put a passphrase on this. No passphrase. Okay, so all you do to enter no passphrase is hit enter again, and it says, hey, enter the same passphrase again. I'm going to hit enter again. So all you're gonna do is just keep hitting enter. You're not gonna enter in any other information. You're just gonna hit enter, and then it's going to give you this random key art image that's going to show you that it did some cool stuff, and it's generated these two files for us, and it generated them in this location. It's going to generate them in this directory right here, root.ssh. Okay, so how can we see these files, or how do we know what this is? So what I want you to do is, I want you to do an ls-l. Is there a need for passphrase? No. So no need for passphrase. Don't put in a passphrase. Yeah, you don't need a passphrase here. In fact, don't put in a passphrase, because I don't think it will allow you to enter in a passphrase. Leave the passphrase off, or you might have to do some weirdness with your git config. Just make sure you don't put the passphrase there. All right, so I'm gonna do ls-la. I don't think either one of these is hidden, but I'm gonna do it on whatever folder they put right here. So /root/.ssh. All right, and I'm gonna look in there. These are the two files that is just created. Yours might be named something different. Yours might just say ID_RSA or something like that, depending on what hashing algorithm was used. But it generates two files, and these are the pair. Okay, the one with the .pub on the end of it, this is the public key. This is the one that you can move around to all the computers that you want to have access to this system. This is the one that can be shared. ID, the one without .pub, this is the private key. This is the one that you do not want to put, that you do not want to give anybody else. Okay, you don't want anyone to know. You don't want anyone to have this. Okay, so keep that one secret. All right. Would you recommend using the config file for managing multiple keys? Yes, Josta. 100%. We're actually going to talk about that in a second. I think that's like the next slide. Yeah, we'll talk about SSH. We'll talk about we'll slide through it a little bit. We're not gonna spend a ton of time on it. I'll set it up very fast, but we'll talk about it because it is a topic of concern that a lot of people run into and have a lot of trouble dealing with while they're doing stuff. So yeah, so we have these two files here. So here's what you're gonna do. You now have your keys. You can look at them if you want. Feel free to look at them. Cat in the name of the file. You can look at it. It's going to be a bunch of gibberish that, you can't make any sense of, but no big deal. But now, once you do that, okay, what you're going to do is GitHub has walked you through this. Once you have these keys, what you're then going to do is you are going to, on the page that it allows you to do this, when we go to add a new one, we're going to take this and we are going to add our private key here. All right, so we're gonna put our private key on this system. So I'm not gonna show me doing it. All right, I'm not gonna show me putting it here, but we're gonna copy and paste it and put it right here, okay? That's all we're gonna do. So on that SSH page, you know, in your settings here, go ahead and go down to new, or go up to new SSH key, click new SSH key, give it a descriptive name. So I'm gonna say, hey, I'm gonna call this, Tracks Linode server. Okay, something that helps me identify what this key was created with, or where it was created, the machine that's going to be authenticating with this. And what you're going to do now is you are going to look, you're going to type in CAT, and you are going to type in the name, you're going to copy and paste in this file right here. So you might have to do a full pass. So you want to do cat, remember where this is located, /root /.ssh / whatever the name of the file is. And when I hit enter, it's going to spit out everything that's in that file. Okay. And actually, you know what? I'll do it so you can see it, and I'll just create a new one. I don't really care all that much, but you could copy this. Well, actually, you copying this wouldn't be super helpful for you, to be 100% honest. You wouldn't have access to my stuff because I haven't shown you the public key yet. So it's not a big deal right now, but yeah, so this is what it looks like. Okay. Actually, that is, hold on. Oh, this is a different hashing algorithm. Is this what this looks like? Oh, I'm tripping. Yep, I forgot the .pub. Thank you. The .pub. Sorry. So it looks like this, and this is shorter. If you did RSA, it would actually be longer than this. But this is the line right here. Let me clear it out so you can see it a little more clearly. But not a big deal. Now that you have both of those, not a big deal, because I haven't enabled this on my account. It's okay that you guys are seeing this. But this is the line that you need to copy. All right, so you copy it. And all you do is go over here and you paste it in there. Great. Okay, once you do that, you will now, from that system that you've created this on, you will now be able to authenticate no problem. It's okay. Yep, I revealed that private key, but I'm not gonna submit this. So that private key is useless. I'm not using it for anything. Okay, now I'm gonna generate my own I'm gonna generate my keys again so that you guys can't see, it, but you can't do anything with it right now, so it's fine. So I'm gonna clear it out. I'm going to rm-rf /.ssh, and we'll go ahead and we will just do it again. There we go. And now I will do this. Let's see that pub. Let me see. That the public key, said the private key. So the public key is the one with the .pub. Sorry if I said you were supposed to paste in the private key. Sorry about that. Public key. My bad. Public key in the GitHub. So the public key is kind of the lock that you can use on all kinds of machines. So any kind of machine you want to authenticate with, you can kind of push it around to all the machines that you want to put it on. But you kind of have you keep the private one, the one that's important. And you only put that on the machines that you want to be able to access these things, because it's kind of the key to the lock. So my bad if I just, got my words mixed up there. So I did that again. Let me cap my public key really quick. Let me go ahead and stick it on in here so that now I will have access just like you all. And it's gonna ask you for your password, which sometimes I forget. All right, cool. So it's in there. Great, we're good to go. So now what this means now any repository that I've created in my account, I wanna have access to that. So I can now clone whatever I've created. That means I can also push to whatever I've created as well. So what we could do, just to kind of show you that, it works the same way, I'm gonna get out of here. And I'm actually going to delete this. I don't need to. I could just change the remote, but I'm gonna completely delete our amazing app, and I'm gonna go back into GitHub, and I'm gonna reclone it because it's no big deal. If you are properly utilizing Git, if your whole thing is blown away, just if all your work was saved, all your work was accounted for in your commit history, it's no big deal. But I'm gonna click here into this repo. I'm going to clone it, but again, I'm going to choose the SSH option for this. And I keep clicking on the wrong thing. Sorry about that. And I'm going to git clone and notice how the URL is different. This is an SSH. This is a command. This is an SSH command to log in. It's the user at the URL and then colon the location. So we're going to do that. It's going to say, hey, by default, because of the way the system is set up in that .ssh directory, it knows what files to use by default. Okay. And it says, hey, the authenticity of host github.com can't be established. RSA key fingerprint, and it gives you some information. It's right now, it's utilizing that key pair right now to be able to log in and saying, hey, this is the first time you're connecting. Are you sure you want to make this fingerprint? And you say, yes, I do. It will only ask you this the very first time that you need to connect. And then it says, cool, I see that you are the person that, you are who you say you are. And you have the right credentials. So therefore I will now allow you to download this thing. Okay. So this may seem a little bit weird to you because this is you can also do this. All right. You can also do this to my repository because you can do this with any public repository. You can clone that public repository. This gets more in depth when you have private repositories that only you can have access to. And also when you need to push to repositories, because you can only push to repositories that you have access to push to. Yeah, them hackers, they'll mind, they'll mind a lot. If I deleted the public key, is there a way to recover it using the private key? No. Well, at least not that I know of. I'm gonna say no. I think Digital Byte, I agree. I don't think so, but yeah, you'll never be able to recreate it. But I never want to say never because every time you do that, someone takes that on as a challenge, and someone's like, yes, I can, and then they do it, and then they take all your stuff. But as far as I know, no. So if that should ever happen, it's not a big deal. If you should ever delete your public key, it's not a big deal. Why? Because then you can just go and generate new keys and you can go back into GitHub and replace it. So it's not a huge deal if you do. So that's the next way. So username and password, and then this one right here. Can you ask who you share it with? What do you mean? What do you mean who you share it with? So when I say you can share it around, I don't necessarily mean with other people for the most part. I generally mean with other systems. Maybe you are going to be pulling and pushing information from multiple systems. Maybe you have some type of build system over here, something like that. You can use the key for that. But generally, I recommend that you use completely different keys for every different system, so that it's easier to see who's doing what and where. But yeah. Okay. So the last thing is GitHub CLI. This is the last way to do it, and this is my recommended way of doing this now, to be 100% honest. It is a really good tool. We're gonna get it installed and show you how to use it. How often should you rotate SSH keys? It's a good question. A lot of times in an organization, you might not have to worry about it so much because you'll probably have some type of requirement, security requirement for that. Maybe it's 2 months, maybe it's every 6 months. I generally rotate my keys. I rotate my keys pretty often, but not to rotate them. I generally do it because I reinstall my operating systems a lot. It's just what I do. I don't know why. I like my operating system to be, renewed and refreshed. And so, I'll probably do mine every 3 months, every 3 to 6 months. But I would say 6 months for personal keys when it's not a big deal. I mean, if you're just pushing stuff that doesn't really matter, I wouldn't sweat it at all. But in an organization, 90 days is a common occurrence as well. So, it's whatever your security posture needs to be. If you change your public key to encrypt for SFTP and lost it, to ask from a vendor which public they are using. Can you ask? Yeah, so you can get from them. If you're saying like you shared multiple public. I assume they would give it to you. I assume they would, if you were unsure which public key they had, yeah, I mean, they could probably give it to you. All right, so we're gonna get the GitHub CLI set up. Let me see. Download for Windows. No, I don't want to download for Windows because I'm downloading it on Linux. So just go ahead and click view installation instructions if you want, or you can download it for the platform that you're on. It should detect it automatically for you. I'm going to install mine on Linux right here. So it's available via Homebrew. Nope, I'm not going to do it via Homebrew. Very interesting. Linux installation docs. Let's see what other way they tell you to install it. FreeBSD. It looks like on. No, we're not on Red Hat. Ubuntu. They should. Oh, here we go. Right here. So they give us some installation instructions. I'm on Debian-based distribution. I'm on Ubuntu, so I'm going to follow this section right here. You can do it however for whatever platform you're on. Again, it looks pretty easy for Windows and Mac. Mac looks like you can use Homebrew to do it. Brew install GH. That's great. And so I'm going to do it via these couple of commands here. Take it. Let's actually put this side by side just so I can more easily copy it. Copy, paste, and copy. Just copy the lines one by one to get everything installed. And so what this is actually doing is it's actually utilizing Linux's package manager to install this. Again, if you want to learn a little bit more about package management, we will be covering all the Linux stuff Thursday through Saturday. So you can come through and better understand what's happening when we're typing in stuff like this and we're copying and pasting. All right, and we'll do a sudo apt update. That's this line, I just typed it in because, muscle memory. And now we are simply going to do an install. We're going to install the GH tool, okay? What's that? Nerfherf, welcome to the channel. Love your name. What's up, Crypto Linux? Welcome to the channel as well. Break, good to see you. Katashi, welcome as well. This is good to see you all here. All right, so now we have the GH tool installed. Again, the GH command line tool, the GitHub CLI tool is simply a tool for the command line, which allows you to interact with GitHub and to do all the things that you need to do right here from the command line, which is surprisingly helpful. The more that you can do from the command line, the more that you can automate, and it keeps you in one location, which is super duper helpful. I really like it. I really like not having to go to GitHub very much if I do not need to. All right, so now that we have it installed, I think all you do is, I think there's like a GH install command. I can't remember. Let's see, installation, and after I install it, they're not telling me. After you install it, I think you simply do this. Let's go back over here. And let's go ahead and, whoops. GH, let's see, auth. Okay, GH auth. Okay, so that's the first thing that we're gonna do is we're gonna type in GH auth, and it's gonna allow us to authenticate with GitHub, I think. And no, there's like a auth login. Okay, auth login, but I think there's like a setup. Let me see. Let me see. I only do it. I only did it once or twice because you set it up on a machine and then you just use the command line. I think we could just do auth login, but I thought there was a setup. Maybe there isn't. Download. I already installed it. Manual. Okay. Just start with auth login. All right, got it. So let's do that. So we'll do GitHub auth login. And this is going to allow you to set some things up. So I want to log into github.com, not GitHub Enterprise Server. You want to log in with github.com as well. So use your arrows to select, just leave it right there. What is your preferred protocol for Git operations? We just learned about this. This is exactly what we're just talking about. What protocol do we want to use to authenticate with this system? And I'm going to say my preferred is SSH because that is what we just set up. That is my preferred method as well. Melky, what's up, man? First off, shout out to Melky Dev. Good to see you. Thanks for coming through. We're just having a little Git fun, setting up the GitHub CLI right now. All right, so now it says upload your SSH public key to your GitHub account. So we've already done this. So the GitHub CLI will actually do it for you. If you haven't done this yet, it will do it for you. I'm gonna click skip because we've already done this. So just arrow down and click skip, no big deal. Then after that, we are going to, how would you like to authenticate with GitHub CLI? I think this is, this can be one of the coolest things, but it will mess up if you choose the wrong thing like I'm doing now. Right now, I am logged into a remote server. So if you click on login with a web browser, that's fine. You can do that, but make sure you're on your local machine. When you do, it's gonna attempt to open up a browser and it's gonna do the authentication and authorization for you. That's great. Instead, I'm gonna need to type in paste authentication token, okay? And when I paste the auth token, I can't remember what happens here. Hold on, let me go back and do this again. And let me click the first one. SSH, skip it. So when I try to do web browser, it says, hey, first copy your one-time code, enter open up github.com. So it's not gonna open up github.com for me because again, I'm logged into a web server, but I lied because I'm using VS Code and it's the remote desktop stuff, not desktop, but the remote connection stuff. That's interesting. I'll paste it in right here. That's nice. Okay, so what it's gonna do is it's gonna allow you to go through GitHub's OAuth, and it's gonna allow you to authorize this connection, and this connection will remain active. This actually, if I was just SSH'd in, if I wasn't using it the way that I'm using it, that probably would not have worked. And I think I remember that not working last time. So that's great. Phenomenal. It says, hey, you've authenticated now. You're good to go. We know who you are. We understand how you like to authorize with the stuff here. And you're good to go. Now we can use the GitHub command line tool to do all the things that we want to do. It's still going to utilize one of those protocols. But the reason why I wasn't so pressed to tell you about it is because even if you decided to use HTTPS, and like I said, it's normally very annoying to type in your password, username and password every time that you need to upload something or you need to push some code. This will handle the authorization and authentication for you. So you can utilize that if you'd like, but I still think SSH is the way to go here. So we're in, we have the GitHub CLI, you know, so if you ever want to see what commands you have available to you, you can do this. And it's really nice because you can do everything from here. And it is something that I recommend you take a look at. We're not gonna do a ton with it in this course because it's less about learning what GitHub has available and more so about the basic Git workflow. But I just want you to know about it. You can log in using the GH auth login to help you out with it. And there are tons of options here. And it is really nice. We'll use it a little bit, but we're not gonna spend a ton of time learning how to use it right now. All right, so those are your three options. Really, there's two options, and the third one helps you with the other two options, but those are your options. 750, we're gonna skip over. We'll come back to the multiple accounts thing in the end if we have time. It's not super important, but actually I will share with you a document. Handle multiple, just so you have a guide to do it. But if you decide that you would like to utilize SSH keys, a common problem is you will, let's say you're going to work for a company and you have your own personal GitHub account and you're working off of your computer and you've been using that GitHub account and you have SSH keys set up for that account. Your job makes you sign up for another GitHub account to handle their work, and you want to do work for both of these things off of your same computer. You know, you don't like working off of two computers. You'd like to work off of one main computer, and you want to be able to authenticate with either of those accounts when you need to do them. If you're using SSH, notice how we never had to like tell it where the key was or anything like that. So by default, it will utilize a default key that's in the directory. That only works if there's only one, and it also follows a naming subset, whatever. But if you have multiple different accounts, you have to be able to tell it which key to use, and you got to figure out some stuff. We're not going to talk deeply about it right now, but there is something called an SSH config. And what an SSH config allows you to do is allows you to set up a file that says, hey, these are the settings that I would like you to apply to my SSH connection when we try to access a certain host. So let's say we were trying to SSH into google.com and we had a specific key. We say, hey, whenever you go to google.com, use this key and use this, whatever other information we need, use this information to log in. And so we could develop a configuration file that allows us to work with that. Like I said, if we have a little bit of time, we'll set one up. It's kind of confusing. I'm not gonna lie. It's the setup of it's not confusing. If you are brand new to SSH and you're brand new to an SSH config, it is a confusing paradigm, because not only do you have to add your keys and tell it which one you're pointing at, you also have to do some management of the URLs and to kind of explain how the URL gets, read even though you changed it. And we'll talk about it if we have time, but just wanted to present to you, there's going to be a time when you want to deal with multiple accounts via SSH keys. The way that you do that is through an SSH config, and I'll share this with you. It is a little like it can be kind of tough to follow at first. I would like to go through it with you, but we'll do that if we have time, because that's less important. All right, now we want to get into the good stuff to make sure that we are diving in and learning what we need to learn. Ooh, that water got cold, real cold. All right, tracking changes and comparing differences. This is good. So I'm actually going to use a different. Let's see. I'm going to Google popular GitHub repos. I'm gonna grab a random repo that I don't know about at all. Okay, discovering interpretable GAN controls. I don't know what that means. The next big thing after Bloomberg terminal, a GameStonk terminal. Yes, this is what we have to use. GameStonk terminal. This is phenomenal. I don't know what this is, but it's exciting. We are going to take a look at this, and we are going to. Does it just have the GameStop price like in there at all times? What is this? Okay, whatever. Doesn't really matter. I'll send you this if you wanna use this as well. But I'm gonna clone this, and this is what we're gonna use. I'm gonna use this as, because there's a bunch of code in here, I want to use this as a as my example for today as we're going through some of these things, because there's gonna be a little bit more to play with because it has lots of different files. So first thing I'm gonna do is I'm gonna go over to my terminal, and let me get out of here. And in the right directory, I'm going to git clone. And did I ever add that URL or copy that URL? I'm gonna git clone, and I'm gonna clone this public repository. Like I told you, you can gain access to any public repository from GitHub. Just cool, Pool. Thank you so much for the tier 1 8 months. That's love. You've stuck around for a long time. I appreciate it. Okay, so now I have that code here. It's gonna be in the GameStonk terminal folder, and there's a bunch of stuff here. So I'm gonna reopen this up really quick so that you can see it in VS Code, because I think it'll be easier for us to know what's going on. And this is where I'll also introduce you to the amazing integration that Git integration that VS Code has. Again, I prefer the command line. I prefer it, but I can't knock the way that visual representations can help you understand what's happening in Git, and visual cues that are pretty helpful as well. There's also another, if you want something more visual as well as we get deeper tonight, there's another one called Git Kraken. I spelled that completely wrong, but it's a graphical user interface for Git, and it can help you visualize what's happening. It is, again, while I highly encourage you to also learn what you're doing from the command line, you know, a tool like this can be super helpful for you to kind of understand what's happening. So I'll install it. I don't use it, so I may not be able to point you in the right direction. Like I'll try to open it up so we can, you know, see it. And I actually don't even know if it's going to open up properly with our code, because I'm doing it from WSL. Don't really know how that works, but you know, I'll get logged in real quick. It's fine. To get cracking. And yeah, it'll just give me some good visual stuff. If we need it, I'll try to remember to go back to it. Someone remind me if we if I don't go over it with you. Do you recommend GitHub Desktop? I don't know anything about GitHub Desktop. Like I said, I use the CLI exclusively. So sure, I'm sure it's fine. I have to imagine that it works well. So yes, GitHub Desktop, beneficial for sure. But I have to, like, in my mind, the GUI is slower, but maybe it's not. I don't know. I don't know. But maybe it's not though, because I have found that when I was using the integration that was here inside of VS Code, it didn't really slow me down. But I think it is a beneficial skill to know what to do from the command line. Because sometimes there are places that you might go who may not allow you to actually install GitHub Desktop on your machine, or Gitkraken, or any other of those tools. Some of them have a pretty secure list of things that are allowed, and you know, for you to do it, you may have to, like, you know, beg the IT guy. Certain companies can be frustrating, but yeah. So right now, I've opened up this repository here in VS Code. If you're unfamiliar with VS Code, it is simply a text editor. It's got to be the most popular text editor. It has to be. It's free and open source, made by Microsoft. It allows you to edit whatever you want. It's really cool. It's very extensible, really nice. It's pretty performant as well. So we got this stuff here. Now let's talk about how we can track changes and everything. So how in the world do I see the history of code? How do I know what the history of this code base is? Okay. The way that I do this is by utilizing the Git log. Okay. So you can see this information in GitHub. All right. I could see it from here. All right. Remember, this has 706 commits. There are 706 modifications to this code repository since its creation. And I could click in here and I can see everything that's happened in the order that it happened. I can see exactly what happened as well. We can see all these things as well. The way that you find this out is utilizing the Git log. And let me open up my terminal, and I'll just type in Git log. All right, and this can be hard. I think everything from the command line can be tough to parse when you're first learning. That's okay, don't sweat it. Git log goes from the very top down. So the very top entry right here, remember we talked about the head. This is the pointer to the current branch. Okay, so head is at main right now. That's the branch that we're on. This is the most recent commit. This is the most recent change in the entire history of this repository. It also gives you the commit hash. It's a unique ID. If we take a look at this commit hash, let me go to, so let's look at this 6A4, 4F543. If we go in here, we can also see that, oh, it's actually the first part of the hash, 5C33F4D. Is this right here. It says merge pull request number 196 from Buzz. And if we go back over here and look at it, it's actually 5C33 F4D. Great. And this merge pull request number 196 from Buzzcraft. So what you see here is the same thing that's mirrored over on GitHub. It's the same thing. That's just showing you the log of transactions, showing you what happened, who did it, when it happened. So you get the commit ID. You get who the author of that was. So that author name will be whatever name you put in there when we set up our Git config. The date that it happened, and the message that was added to that commit. So you get a bunch of information, and you can just scroll down with your arrows if you like, and you can go and you can see every single commit. I can see all 706 if I just keep scrolling down, but I can just hit Q to get out of it. If you don't want to look at it anymore, simply hit the Q key and you can get out of it. So that is how you easily see what's going on, what happened last. How do I know, am I at the right point in time? It's a very quick way for you to see what happened and who did what and when. It is extremely helpful. All right, so that's your git log. What I also want to show you is, hold on, let me so if I do git log on, let's say this computer, take a look at let me go into one of these. If I do a git LG, I get a different view here, and I'll show you how I got this in a second. So git LG, if you type in git LG, you're not gonna see anything. I can go over here and I can type in git LG, and I won't get anything. I have alias, and most people do. I didn't. This is not something that I created. I pulled this. You can customize in your git config what commands do. I've aliased git LG to give me a visual log of things that have happened. We haven't talked a lot about, we'll dive into merges and things a little bit more, but this is pretty helpful as you get more familiar with what's going on, because you can start to see, like, every time you diverge here, these are new branches. Every time you diverge off, you're creating new branches, and these little stars are where commits happened. And when they go from left to right, back over, that means you merged back into another branch. So it gives you an interesting view of the history. So same thing, same information as before, it gives you the hash, it gives you the commit message, tells you when it happened, and it tells you who did it. But it gives you a visual representation of how the data flowed, which can be pretty helpful. How do I see what's in my git config? What's the global one? Yeah, here it is. I'll give this to you right here. And so this is actually the file. Let me show you where it was. If you type in exactly what I typed in, it should open up your git config. And maybe don't vim it. Maybe don't vim it, but edit it however you can. But the command, I'll go back into mine really quick. The command that I've aliased is git log, and then I've added a bunch of options to it. So again, I didn't pull this, someone gave this to me, but I will share this with you if you would like to add in a new alias to your git config. And actually, it's not going to copy from Vim, so I have to cat it instead. And this is the global git config. So remember, we did git config -- global. I didn't put this in manually. I simply did that with the git config command. And so let me go ahead and give you a long command here. Copy, but here we go. RWX Rob, thank you so much for the raid. Again, shout out to RWX Rob. And so if you all don't know what RWX is, again, come through on Friday. Friday, we'll talk about Linux permissions, so you can know what that is. But thank you so much again for the raid. We're just diving a little bit deeper down the rabbit hole. Again, please give RWX Rob a follow. Very, very smart guy, knows a lot about tech, knows a lot about Linux, knows a lot about programming, mentors people. Actually, I think you can, correct me if I'm wrong. Yeah, I'm pretty sure you can, you have you paid mentorship that you do as well. I don't know if you're still doing that. But if you need some guidance, if you need some mentorship, if you want to follow someone who's very intelligent, who you can learn from, please give RWX Rob a follow. Again, thank you so much for the raid. All right, so, whoops, I typed in clear into the wrong place. We'll do clear here. Also, something that I learned from RWX Rob's channel, and I actually ran into it, is I used to always use, if I wanted to clear some stuff off the screen. So if I just do LL here and I have all the stuff here, I used to always just do Control L all the time. And from RWX Rob's channel one day. I was listening and talking, and he kind of let me know that that's not actually a Linux shortcut, and it's not actually going to be available. It's not actually going to be available on every machine. I actually ran into a place where it wasn't available, so I've since backed off, and you'll see me type in clear rather than using that Control L, because it is frustrating when it doesn't work for you. And Control L actually might do a few different things depending on the system that you're on. But you know, just giving you something else that I've learned there. So again, git log is what you're going to do if you would like to see the log of commits that happen and get information about that. It is super helpful. All right, so log is how we do that. And again, it takes a little while to do anything from the command line. And actually, let's open up Git Kraken really quick. I wonder if I can see. Do I really have to do this? I'm not. I'm sorry. I'm not doing that. I don't feel like doing that with Git Kraken right now. All right, so that's the history of the code. Now, how can you see the things that have changed? So Git is all about tracking changes. It's all about tracking modifications. It is about creating patches for the deltas. So how do we see what's changed? Maybe we've made a lot of changes, or maybe we started making changes and we went on vacation and we came back and we were like, oh no, wait, we left this in a place, we couldn't get it working. We're not sure what changed. We're not sure what was supposed to be there before and what's there now. So the way that you do that is using the git diff tool. All right, and it works very similarly to how diff works on Linux, if you're familiar with that. But right now, I'm in the GameStonk terminal repo. If I type in git diff, it's going to give me no output. Why is it going to give me no output? Well, because there have been no changes. Okay, there's nothing that has been changed. But if I go into, I'm just going to pick a file here, and let's say I wanted to go into here and, I say, hey, why in the world are we using Python? We should be using Alpine. Okay, we should be using Alpine, and I save that file. And then I go into the GameStonk terminal section here, and there's a bunch of Python stuff. And I go in here and I say, let's go look at these data frame helpers. And I say, hey, this should be a whole new function here. And I, say def new func, because there needs to be a new function here. It doesn't take anything. And all this function does is I don't know, it prints hello. All right, so we just wrote some code. We spent days, working on this new feature, and we updated some things, and now we have new code. We wrote our function. It solves all of our problems. All right. And so we get in here, and just a little precursor, I want you to see that something changed in my VS Code as well. But I'm gonna say, hey, I don't know what I changed, because I may have changed 20 files. I'm not sure. You do a git status, right? So you can kind of see what's happening. You're like, okay, you know what? I see that I made some changes to Dockerfile. Did I mean to do that? And in my head, I'm like, I don't think I should have made any changes to Dockerfile. I'm not sure what happened. If you want to see all the changes that happened, I can do a git diff. And if I hit git diff, it will show me what file it is. And it'll say, hey, this is what it used to be. This is what it used to be. This is what it is now. Okay, so this was removed and this was added. All right, it tells me what line it's on and everything. And then down here, that tells me how many characters. And if you scroll down a little bit, I can also see all the changes for the GameStonk terminal data frames helper PY file. And I can see that all I did was add some new lines where I added this new function. Again, it gets tough to be able to read this and to understand it. But all it's doing is telling you what it used to be and what it is now. I can also specify something directly. So if I want to see just what happened to that Docker file, and I only want to see that, if I say git diff the Docker file, I can see only what has changed since the last commit here. Okay. So let me now, okay, share the git LG alias. Yeah, absolutely. Let me share it again. That alias was, there we go. That's the alias right there. So what happens if two different people push a change to the same file? Say one person removes a block of code and another person was working on the same block. What happens? We are about to talk about that very soon, Zero Fate. We're talking about that very soon. It is that is the $1 million question, Zero Fate. Like that question is exactly what That's what everyone needs to understand. What happens when someone has removed that block, and that's when you run into a conflict, merge conflict, and we're about to talk about that very shortly. So we changed it, git diff. Now we know what happens. So that's all git diff. That's all you need to know about git diff. Nothing fancy here. There are some extra things you can do with git diff, but by default, this is all you want. Just to get started, I want to see exactly what changes were made in this file. This will help me do it. Now, because we're using VS Code, because so many of you are using VS Code, notice how on the left, this is the Git integration tool right here. Notice how it has this little 2 here. So I'm gonna click on it. It tells me right up front that these 2 files have been modified, okay? So it says, hey, it's the M next to it, the Docker file and this file have been modified. This is the same thing that you see when you go to Git status. And I think this is a really good integration. So same 2 files have been modified right here. Modified, the little M shows you they've been modified. Super helpful. What I can do is if I click on it, Get a VS Code will show me the changes. It shows it to me. I click on it, it shows it to me. I think that, again, I'm a visual person. This is helpful. This is very helpful. I do like this. So you can use this. I just want you to understand what's happening here. It is showing you the difference from the thing on the left to the thing on the right. The thing on the right is the working tree. We talked about that as one of our thesaurus words. Okay, not thesaurus. One of our it's one of our it's part of our terminology list, and our working tree is the actual file that we're currently have checked out that we're working on, and this is the working tree file, and that's what's changed. If we click on this, we can also see, hey, this is what's changed here. Very, very helpful. So you can use this as a visual indicator to see what has changed. Every time you modify a file, it will show you, it'll show it to you here. All right. Now, if we were attempting to actually make these changes, I would say git add, and I would add the files. If you would like to add the files via the Visual Studio Code integration, all you got to do, click the plus. If you want to do a git add and you want to stage the files, all you do is add them just like this. You say, hey, I'm ready to do that. So Docker file is now staged, and now data frame is staged. So now both of them are staged, and we are ready to go. It says, hey, cool, we're ready to go. Take a look at this. If I do a git status, they're staged. So the same way you would type in git add, I can do it visually right from VS Code. That's completely fine. It is not, don't let anyone make you feel bad about it. I think I actually think it's, I think the way that they've implemented this is so good that I think people should know about it a lot more if you're gonna be a VS Code user. You've now staged the changes. It also makes it easy for you to revert. We're gonna learn about reverting and everything tomorrow. And so that actually gets pretty complicated. This makes it a little bit easier for you to do reverts and things as well, which is nice. When you're ready to commit, look at this box up here. Type in your commit message. Say updated Docker file and added game ending function. Okay? When you're ready to go, when you're done, all you got to do is hit this little check mark up here. This is a commit. The way that you go ahead and now change the history of this is to add in a commit. And now we have changed the history of this repo. Okay, so we do git status. And now it just says, hey, you're done, but you're ahead of the origin main. You need to push your code. I don't have access to push my code, but I'll do this to show you that I can't authenticate with someone else's repository. It says, hey, fatal, could not read, make sure you have correct rights. I don't have correct rights to push to this person's repository. I can read the code, I can get it. I can modify it on my own computer. I can change the history on my own computer, but I cannot push it to their remote without authentication. Can you do git add -p? First off, what is the -p? Does that also push? So you can type in anything you want from the terminal here. I don't know if that, maybe put, look, it's got all these options here. If you click the little thing here, I don't use it that often. So it might have all kinds of functionality, so maybe. I'll leave you with a maybe here, but I do think I think the visual indicators are good. So even now, even though I still do everything from the command line, I can see exactly how many files are changed over here on the left. It's super helpful. And if I'm having trouble, especially with merge conflicts, when we get to merge conflicts, I think if you don't use VS Code for anything else, VS Code you should use for handling conflicting merge problems. Okay, that is like honestly the reason I know what I know about the tool is simply because that's what I was using it for. I was like, once someone showed me how you can easily resolve merge conflicts using this tool, it changed everything for me, to be honest. And I use it purely for that. That's the only reason I installed it. HP pipe all output into less. Oh, okay, I could have just manned that, but yeah, sure. You can see the commands of the Git output from the, oh yeah, the built-in terminal. Yeah, you can see them all from here. Yeah, and actually I think they have a little output section. So even when you type those in, I think you can see the outputs by default, which is kind of nice. But yeah, so those are two quick little topics there. How do you see what's different? Git diff. If you want to see what things have changed, Git diff is how I can see exactly what changed. And if I want to see the history of this repository, if I want to see the history of commits, the way that I do that is with git log. All right, git log. It makes it easier, but nothing beats understanding how to resolve merge conflicts in a pure text editor. I agree with you. I 100% agree with you. I 99% agree with you. The only reason I 99% agree with you is because, you know, it's one of those things where it's like the teacher is always like, you won't always have a calculator in your pocket, and you say, hey, don't rely on this thing because you won't always have it. I feel like if you're writing code, and you are, you know, if you're writing code, if you're developing, I feel like you're gonna have access to your text editor. I feel like there's gonna be almost no situation where you're not gonna have access to your text editor. Your text editor may not be VS Code, but other text editors have integrations, Git integrations that help as well. VS Code's I think is particularly good, but you know, 99%, I do agree. I agree mostly. Okay, so cool. Do I want to do? I'm trying to think. The history. Okay, that's cool. And just a little thing on the history. If we go back to our other brand, let's go to another folder real quick. I'm gonna SSH in again over here, and I'm gonna CD into what we created yesterday. And in here, how do you see your branch? The way that you can see your branch is either through git status or again git branch. You want to see it? If I should do this and I type in git log here, notice how I only have 2 commits here. There are 2 commits that are part of the main branch. All right, but I'm gonna git check out. I know we have some other branches here. All right, if I do, you know, git branch just to make sure I'm on the right branch, I'm on production, and I do git log again. Notice how I have many more commits. Again, you know, these are different, a different series of commits. A branch is a different series of commits. And also notice that I have this tag here. Remember that a tag, it allows you to label a single commit, a single point in time. It allows you to do that. So, you know, we tag this here, but I just want you to see that in the same repository, in the same code repository, you know, you can see the differences between different branches here. They do have different histories, so make sure you are paying attention to those things. As a developer, yes, but as sysops, yeah, I have to work on unknown machines. So yes, that is what I think that's why I agree with you 99.9% is because I come from a systems background, and you know, if you're working on systems, you often may not have access to, very often may not have access to your text editor of choice, almost whenever. But yeah, when and how to utilize cherry picking. I'm pretty sure I have cherry picking on the docket for tomorrow. We can talk about it really quick. When to use cherry picking. I personally say do not rely on cherry picking. Let me just make sure I do have it on there. Yeah, cherry picking is tomorrow. We'll talk about it then, but we'll do it then. But I say only cherry pick in emergencies, to be honest. I don't like relying on cherry picking. I think that if you're cherry picking often, I think that your Git workflow is messed up. I think that you have designed your workflow in a poor way if you have to cherry pick often. I think cherry picking should only be utilized as a way to get you out of jams. You know, I don't think it's like, oh, never use this thing at all. But it's just, you know, keep an eye on how much you're using it. You use it when you need to get. So not only. I take that back. I take that back just a little bit. I'm backpedaling about 25% on that. There are going to be times when someone else has done some work in another branch that you need to grab. You know, there we go. Yes, do it then. But I still think that's a problem with your. I don't think there's a problem with your workflow, but I think you should. I think you should at least take a look at your workflow to see if you can stop doing that, because it can cause. It can make things a little bit hectic. But so a scenario in which you would have to use it is if you are working on a feature, someone else is working on a feature, and they've done some work to support the thing that you're doing as a part of their own work, and you need to grab the work that they've done. You can cherry pick it from their branch and get it into yours. It's yes, do it, but again, just be thoughtful about it. That's all. Thank you much, Sim. I really appreciate the Twitch Prime sub. Thank you so much. Let's see. Yep. Yeah. So SimCity, no, it's not even to revert a specific commit. It is simply to pull a specific commit, pull the like a commit, the changes that are from a specific commit to pull them into whatever branch you're on now. We have to cherry pick often. Help me, Aaron. Yeah, I mean, you know, yes, it's a pain. It can be such a pain. That's the problem. It creates all kinds of conflicts. Resolve the branches first. I say resolve the branches, or be more thoughtful about how you're working on the things that you're working on. Yeah, we do wind up cherry picking somewhat regularly since most yeah, that's fair. And also I think it depends on the size of your team as well. So like, you know, if you're a team of 20 and you're cherry picking relatively often, I get that. I get that. But if you're a team of 4, you know, and you're cherry picking like every single day, but that's a little bit weird. I agree, cherry picking should be infrequent or never feature branches. Yep, I agree. And you know, I'm saying these, I also want to be very clear, because I'm pretty vocal about this on here when we're talking through projects and things. Sometimes I'll bring up things like this where it's an ideal. Like, yes, I'm saying this thing, and I agree that the idea is that I don't want to do this thing, but in practice, you know, life is often much different, and the way that your project may be structured, you know, it may just be the thing. I do think that's okay. I do think that is okay. I just want to be clear about not relying in the beginning while you're learning about these things. I think people tend to see cherry picking when they first learn about it. It's like okay, like I can use this all the time, and you can. But it can create more problems for you in the future. But you know, it is what it is. Security updates, yeah. I think there's a lot of scenarios where it does make sense. When we learn about it tomorrow, do your best not to get into the habit of just doing it all the time. Just, you know, use it when it's needed. All right. So yeah, log and diff, pretty simple there. Fetching and pulling. This one is also fetching and pulling. We talked about the differences between here. It is helpful to know the difference between fetching and pulling. I don't think this will make or break you, to be honest, but it is, you know, we're doing Git Masterclass. We want to know about Git, how it works. What does Git fetch do? Git fetch, all it does is it grabs the updates from GitHub or wherever your remote is. Wherever the remote is set to, it will grab the updates. It'll grab the updates, the updates from the remote, and it updates the remote references. So the internal referencing, the refs that we talked about to those different objects, it'll update the internal refs, but it will not merge that code into your local reference or your working tree. So it says local references. I pulled this directly from GitHub. The reason why I pulled it, I'm not from GitHub, from Git. The reason why I pulled it directly from Git is I want you to see the words and the terminology here, but I do think it makes it a little bit confusing. It grabs the references for the updates, but it does not apply them to your local working tree, okay? This means you will not run into any conflicts. And we're about to talk about merging and conflicts. So keep this in mind right now, and it might clear it all up for you. You know, it might come full circle in a little bit, but you can't get any conflicts. Conflicts are when you try to, you know, get some updates and apply those updates. Sometimes it can't be done easily. Git can't figure out how to properly apply these changes because there's overlapping changes and it's not sure which ones need to be there. If you know, so if you want to see if there are updates, but you do not want to get any conflicts, this is what you want to do, is to git fetch. Git pull, this is what most people do. A lot of people, I actually don't see a lot of people utilizing fetch that often, but git pull, on the other hand, this grabs updates from GitHub or wherever the remote is pointed to, and it merges the remote references that it pulls down into your local working tree or your local references, okay? This is where you can get conflicts. So it's getting those updates and it is applying those updates. All right, so the first one gets the updates. You know, the system knows that things are ready to be updated, but it does not try to apply those updates. Git pull does two things. It executes two commands. It fetches first, and then it merges. It fetches and it merges. So you could do them yourself. You could fetch and you could merge if you like. Manually, it does the same thing as pull. Okay. Git fetch, download, git pull, download, git pull, download, and save. Yeah. Git merge, save, and override. Yeah, that's good. I like that a lot, actually. Yeah. I was inherited a system with a dev and a master branch, which causes conflicts with feature branches and deployments. Yes. Like, that doesn't sound surprising to me in the least bit. Who just joined? Leafsicles, welcome to the channel. Good to see you. Operation Nope, sorry I missed your snowy fiber. Welcome. Jay, welcome. Cosm, good to have you here as well. Thank you all so much for the follows. It's good to see you. All right, so those are the differences there. You'll often pull, and I'm going to show you before I even do these things, we're gonna talk about merging first, and we're gonna create the scenario where these things happen. Let's talk about merging before pull requests. So, git merge, the infamous GIF for git merging. Merging allows us to fold the history of one branch into another, and that's what's happening here. It is taking, you know, you've got a main branch, you've got a development branch, and now they are, you know, they've their own thing. Historical events have happened in each of them, and we can take the information from one and we can merge it into the other, and we can mash those two histories together. And this is, as you can imagine, just like you see in the image here, this is where you can get conflicting things. Just like the question was asked earlier. Let me see if I can go back up and see who asked it. Zero Fate. Zero Fate asked exactly this. So what happens if two different people, remember, Git is a distributed version control system, so it's done in different places. What happens if someone goes ahead and you're working on the same file, one person removes an entire block of code. They say, hey, this, I don't even think we need this because I'm going to implement something else somewhere else. They remove it. Someone else says, hey, I need to update this line here to get my stuff working. And they update it. And now when eventually, when the workflow gets together and these histories go to be merged together, what in the world happens? Well, they conflict. So this is what we are going to talk about. The use for the slides are on point. Yeah, I appreciate it. This is, you know, I can't take any credit for this. Well, I can't take any credit for this one. You know, I just go and I just Google, you know, whatever the word is. I have a good time with it. It is the most fun part of creating slides because I hate creating slides, if I'm 100% honest with you. So let's see what this merging thing is. One, there is a git merge command, which I'll show you, which will allow you to merge, again, those histories together and usually find. So actually, let's do that. We already have, look at this. We already have, two different branches. We already have two different histories of code. Here we have main and we have production, okay? We have them here. We have more things in production than we do have in main. We have more history. So we can use the git merge command to attempt to initiate this this change. And so I'm gonna say, actually, is this right? Or do I need to do it the other way? So if I start typing git merge master, I think this will merge production into main. Here's the the reason why I don't know which order this needs to go in is because if I can help it, I actually never merge. Besides on pulls, I actually don't merge. I don't merge via the command line. I only merge via pull requests. I'm a fan of rebasing. I'm actually a fan of rebasing rather than merging. There are pros and cons to each. But I think Git merge master, not something we can merge. Not master, main. There we go. Main's already up to date. Let me it merges master into the current branch you're on. So I'm gonna check out main, and I'm gonna do git merge. That makes sense. Git merge production. And okay, so this was a successful merge. All right, it says, hey, fast forward, updating, new file.txt. There were 3 changes, 1 file changed, 3 insertions. Great, new file created. That's helpful. Now, I don't know if you remember before, but the history of this was very different. And actually, I can show it to you in GitHub. But if we type in git history now, sorry, I don't know why I typed in git history, git log. I don't know why I typed that in. Now, I actually have, notice how this tag was only on, before, it was only on a commit that was on the production branch at first, not the main branch. And now all of this is here now. And also I want you to see how origin main and origin head are still here, are pointed to this. These are pointers for this thing. It's because the origin is my remote. When it says origin main, it's talking about the remote. So like the remote is actually still behind. This stuff is not yet in GitHub, which is completely fine, but these histories have been merged. If I were to now check back out, if I check that out and do a git log again, it actually has the same commits there. The history now matches up with this because we were able to merge that code in. It worked out fine. We did not have any conflicts. Let's go ahead and let's create some conflicts. So first, what I'm gonna do is I'm gonna git push. Just so everything now is up to date. All this stuff is in GitHub and it's great. So what happens if, and I don't have another account to work off of right now, but you can actually modify stuff in GitHub. So let's go to my repos, and let's say we made a change. Let's say we were on the production branch and we went in to code.txt. And what we did was, I'm gonna edit this file right here. I'm gonna put my name in the middle of line 4. Well, that's not my name, but I'm gonna put some text. I'm gonna put some more text in there. I don't know, I'm just typing in random stuff. And let's say changes were made by someone else. I'm simulating changes being made by somebody else. You can make changes in GitHub if you want. I don't recommend that you do it. When you do, you have to put in some, you still have to commit it. So I'm gonna say, you know, updated code. I'm gonna say simulated other dev pushing code. Okay. So I'm going to commit this directly to the production branch. The code has actually officially been changed now. And let's say that line 4, let's actually say that I was working on this file right here. And I made some changes to line 4 as well. And at the very beginning, I thought it was supposed to go here. My name is Jeff. And I put that in there. So 2 completely different changes made in 2 different places, okay? One person just happened to get their changes in before the other person. So notice that, so first let me show you what will happen. So let's say some changes were pushed to your remote, all right? And you were unaware of those changes being pushed to the remote. Let's see what would happen. Let's see what would happen now. So changes, another developer has pushed changes to GitHub on the same branch that we're working on. Ideally, this shouldn't be a big deal, but they're working on the same branch. Actually, I'm doing this wrong. Let me check out production because that's where I did this at. Okay, cool. Yep. Checkout production, the stuff is going to be here because I didn't make any changes there with Git per se. So someone has pushed some code. I don't know about it yet, but now I'm like, okay, cool. I want to now make my changes. I want to do a git add code.txt, git commit -m, added my name, which is Jeff. Okay. And I'm ready to go. And I say, hey, I've checked the status. I've added my changes. I've committed. I've changed the history. So now I want to push it. And when I try to push, it's actually going to fail. Okay, I'm actually going to get a fail here. It's going to say, hey, you tried to push some new refs up, but it didn't work. My updates were rejected because the remote contains work that you do not have locally. That is a very telling thing. It's saying, hey, there's some stuff up in that remote that you don't have down here. And before you can properly change the history, you need to make sure that you've updated the historical document. You've updated, update this logbook and make sure it is correct. So it tells you here, if you go through, it says, hey, you might want to do a git pull before pushing. And so I'm going to do a git pull. All right. Notice that what it says here is it says, it went to go do the pull. It went to go pull the objects, which it did, auto merging code.txt. So it attempted to merge the changes from those two histories. Conflict, merge conflict in code.txt. Automatic merge failed. Please fix the conflicts and then commit the result. So when it can't do what you want it to do, you have to do it manually yourself. How long do you think a coder can code in a day? About 35 hours is top tier answer, TV Josh, top tier for sure. Can code in a day? Like, if you really mean hands on keyboard, like really focus on the problem, man, I think that effectively, if you're working, so I think the answer is different when you're working alone versus if you're working with someone else. If you're working alone, me personally, and what I've seen is, I think most people can only go maybe 2.5, 3 hours at a time. Then you got to take like a little break. So, if you really need to get something done, you might be able to put down a solid 12 hours throughout the day. Yeah. I think you can get through it. I think you could get through a 12-hour coding day. I think you'll be fried though. I think it'll be exhausting. Like if you're actually solving problems and you're like thinking through things and looking up stuff, like it gets very, very exhausting. Like it's crazy. 35 hours, that's top tier though. I like it. 12 was max, exactly. Why does college exist? Yeah, yep, 100%. I'll be able to get a burst of inspiration, but you can't sustain a 12-hour day. Yeah, like I think if I did one 12-hour day, I would be. So the thing is, what's interesting is, I wouldn't be able to do it. I've had during COVID, I had not during COVID. We are still, COVID's still a thing. During the initial lockdown, I had all of my days were like 16-hour days. But I was not coding all that time. In meetings and coding for a lot of it. But it was exhausting. It was exhausting. Definitely exhausting. Okay, so you now are experiencing the most difficult part. We have now created the most uncomfortable scenario while utilizing Git. Merge conflicts. This is what everyone's afraid of, and doing this properly, it has a bad rap because it does let us know where it received it at, but we don't really know what to do with it. Okay. And let's look at the file as it is. Before we look at it in VS Code, I'm going to show you this file. Okay. Look at this. This is not helpful to us at all. But what it's showing you right now is, okay, the current head that we're looking at, the current branch that you have locally, this is the stuff. It wraps it all for you right here. It says, this is the line this is the code that I know about. But here's what's incoming. This stuff is incoming from this commit. I don't know which one to use. I don't know which one is right. I need you to fix this for me. Okay, so it added in these lines. These lines were not here. It wrapped it up for us, and now because I know what those mean, I can go and choose which one is the right one. How do you choose which one's the right one? Well, this is a people problem. This isn't a technical problem. This is, hey, I need to go talk to that other developer and figure out what's supposed to be here. We need to talk and understand, you know, why there's a conflict, and we need to fix it. Or it might be syntax or something where it is easy to fix and you can resolve it, or maybe something isn't needed anymore so you can resolve it. But you need to, you know, this often is a collaborative process. You need to figure out what's happening, and you need to figure out what's supposed to be there and what's not supposed to be there. So this is actually very unhelpful. So this is super easy because it's one line. This gets super complicated when you have many files, many different sections. It can get super crazy and super annoying. And so like the way that we would have to resolve this is I would literally go through and I would remove all these extra lines, and I would remove the line that I didn't want and put in the correct code. But this is where VS Code is amazing. Okay, VS Code is super amazing for this. So also, if you want to change branches in VS Code, all you gotta do is click right here at the bottom, and let me go to oh, I'm in the wrong I'm not even in the right thing. Hold on. Tracks, Git, not Git code. Open it up. I'm in the wrong directory. But now, if I'm in the production repo, look at it, it gives me a little exclamation point over here in Git. It actually gives me an exclamation point in here, and it says, hey, there are problems. It shows you exactly what we just saw. But it gives it to you in a better format, I think. And it says, hey, here is the current change that we are trying to make. Here is the incoming change. Here's the one that we are trying to merge in, and this is where they're conflicting. It makes it easy because instead of me having to manually go in and remove the different lines, I can either accept the current change, and the current change is the one that is on my local branch. I can accept that one, or I can accept the one that's incoming, or I can accept both. Accepting both can be wild, and it can cause a lot of problems. So I'm gonna accept both over here. Guys, I just wanna see what it's gonna do. Notice the difference here is, hello, my name is Jeff is here, and Aaron, this is good, is here. I'm gonna accept both and see what it does, and it's just added in both lines here. All it really did was add in both lines. That's not really what we want, but you can accept both and it handles it for you. If I'm saying, hey, I didn't save this file, so I can actually close it and go back and just accept one of them. So maybe I accept the current change, and it handles it for you. It removes all the extra pieces, and it's super nice. Schwarbomb, thank you so much for the Twitch Prime sub. 3 months, that's love. I appreciate it. Good to see you. Also, the Golden Boy, thank you for the follow. Circa, thank you for the follow. It is good to see you. And yes, this is a 3-part Git tutorial. Yeah, oh, Yamim, or Yami. Yeah, I tried them all. But yeah, yes, G-Doc, yes, it is so much easier. Yami works perfect. It is, in fact, it's a lot easier. I can't even rip on it because, so in a simple file like this, again, in a simple file like this, you know, managing this myself, all I would do is go in and I would say, okay, I want the top change. So I'm gonna delete this line. I'm gonna delete this line, delete this line, delete this line. And now I've solved it and I have to save it. Again, you often will be presented with more than one conflict, or the conflict will be much larger and more complex. It is much easier in VS Code because it will take all of the changes and it'll handle it for you in a very beautiful way. And so I made the changes, but it doesn't save automatically. So now I will save it there. And now that I've saved that, what has to happen after that is you then have to do a merge commit. Okay, so I've merged some changes here, and now I've got to do a merge commit, and I have to I'm gonna do this from the command line so that you can see. But yeah, have you covered multiple branches? I always have that problem. What do you mean by covering multiple branches? Like utilizing different branches? That's kind of what we're talking about now. We definitely will, all the examples and things that we're gonna go through, we absolutely will be utilizing multiple branches. and merging. We're gonna talk about Git workflows and stuff as well. So yeah, we'll definitely cover that. Okay, so I've resolved it. Well, I feel like I've resolved it. Do you really want to write it? No. I don't want to change it. Let me get out of here. So we cleared it up via VS Code, and I do a git status. All right. Now that I have made the changes, I need to do the same thing. I need to add it. Git commit -m. Resolved merge conflict. Resolve merge conflict. And then if I do a git status, I have now made those changes. It says my branch is ahead of production by 2 commits, and I can go ahead and now I can push it. And now everything is resolved. So we got that merge conflict we didn't even get that merge conflict from trying to merge one branch into another branch. We got that merge conflict from doing a pull. What does a pull do? A pull fetches the updates and it also merges those into the current working directory. And that is how we received those conflicts. Let's talk a little bit really quick about exactly what Yami said, multiple branches and what this merging means and what a Git workflow looks like. Okay. Let's what's happening here? No, hold on. Oh, is this on the right? My pen is not opening up. Hold on. Is it 2? Whoa, my pen's not working. Hold on. I don't like this. I don't like this at all. Well, the thumb button's not working. Let me open up whiteboard. It probably just needs to be restarted because of those updates that were there. All right, so this is how a Git workflow would go. Let's say there's a person here, and this is dev 1, and this is dev 2. All right, dev 1 and dev 2 have been tasked to work on 2 different features of the project. Dev 1 has to change the title of the web page, and dev 2 has to maybe create a button. Okay, so here's what would happen, and don't sweat this. I'm going over it right now to give you some context. We're actually going to dive into these workflows deeper tomorrow, but dev 1, dev 2, they both have their tasks. This is how it generally will work. This is a very basic workflow. This is how it might work. So let's say there's already a main, the project has already been going on. They've been working on this for a little while. So, maybe there's been, imagine there were, 100 commits or something, whatever. But now, we're here now, okay? And we're just, this is the main branch. This is the production branch that everything gets deployed. So what would happen is at the point, these 2 people have been tasked with this at the same time. So what happens is they say, cool, I'm going to make what's called a feature branch. We'll talk about feature branching, but I'm going to make a feature branch to work on this new feature that I'm trying to implement. So dev 1 may make a feature branch off of this. Okay, so make a brand new branch here, and we'll call this feature title or something, whatever, it doesn't really matter. That's what that branch is called. And so maybe this person, this developer has to, throughout the process, they've got to make one, they make 2 changes. They make 2 commits to be able to update this title, okay? At the same time, the other dev also creates a new branch of history, okay? And we'll call this feature button. And at the same time, they're working, and their button is kind of complex. And so, they actually have to get, they make a bunch of commits here. And when developer 1 is ready, says, hey, my stuff is good, they're going to attempt to merge. This timeline keeps going kind of. It doesn't really work that way because it's not a timeline, which is kind of annoying. But, just imagine it's a timeline. Nothing happens in between here. But when developer 1 is done, they merge their code. So they made a bunch of changes, they merge it. back into the main branch, okay? And the history of that feature branch is done. It should be done with. And so they merge it back in, that history is done. But notice how this kind of keeps going. And what ends up having to happen is ultimately before this person is able to merge back down to here, this is gonna fail. It's not gonna allow this to happen. The same way that we saw before, it's gonna say, hey, there's some updates that you don't have. So the way that it keeps the history, it keeps the history in a state that that works still, is before this person can merge back in, they now have to pull this data. They kind of got to, wherever they do it, they got to merge everything back up and fix all the conflicts that happen. They got to take the data that's in this main branch, get back up to speed, okay? And once they're back up to speed and they merge everything in, then they can merge back down, okay? They got to get all the updates that have happened. So they have to get this update here, has to get into this branch somehow before it can be moved back down. It's a little bit complicated. We'll dive deeper into it so you can understand the workflow a little bit, but that merging that happens is something that we're gonna do really fast. So let's act like we are dev 1 and dev 2 really quick. So here's how it happens. Let's check out main. Okay, let's actually go to VS Code and let's go back and let's check out the main branch, okay? Also, when all this happens, I actually probably need to do a pull. You should always do a pull first. Before you do anything, you should do a pull. So I'm going to go ahead and I'm gonna do a git pull. All right, already up to date, we're ready to go. Currently, I'm dev 1. Dev 1 says I need to create a new title thing. So we're gonna do git branch to see what branch we're on, and we need to start from main because we're all starting from main. And dev 1 will say git checkout -b, and they will call this whatever they want, and we'll say feature what do we call this? Feature dash title, because we're updating the title of the website, whatever. And they check this out, brand new branch. If we do git branch, this is the piece that we just did. We're on the feature branch here. We just did this part right here. We branched off, okay? So we're basically right here. We've created a new historical lineage for this thing, a new series of commits that are starting from this location. All right, and so now we're gonna go ahead and put in our title. At the very top here, I'm gonna say, look at all these. This is an amazing title. Okay, dev 1 has done their job. All right, it says, I'm good, I'm ready to go. Let me go ahead and commit that, git add, code.txt, git commit, -m, added, web title is gonna be our commit message, and we're gonna git push, okay? Origin, what do we call this? Feature title. Okay, so dev 1 has done their work on their own branch, their own history. Okay, git log. It has some updates on their own history. This is only on this branch of code. It is not a part of the main branch yet, okay? At the same time, okay, imagine at the same time, at the same exact time, developer 2 creates a branch called feature dash button. Okay. Dash button. They've created it and they go ahead and they do their work. And you can notice the title is not updated on this branch right now. The title is not here. Even though we just, dev 1's working on that. Imagine dev 1's working on that. Dev 2 says, cool, I'm gonna go ahead and I'm gonna go in here and I'm gonna create my button. And instead we're gonna do some stars here. And we're gonna say, this is a button. And we'll put a star here. Make it look like a button, kinda. All right, so we got a button. And actually maybe we do this and Make it a little more buttony. Okay, this is a button that is our web button. Very, very exciting, okay? And we take that. All right. Number two, dev number two, created their own feature. They created their own branch and they've done their work. So they're gonna do a git status, a git add. Okay, do git status again. Git commit, -m, added button. Spell button wrong, whatever. Okay, so the -u command, that's a good question. The -u command is whenever you create a new branch. Whenever you create a new branch locally, the remote GitHub does not know about that new branch yet. It has nothing set up. It doesn't know how to track this new branch at all. So if I do a git push, the very first thing it'll tell me to do is say, hey, you know, this is local. If you want to push this, you have to set up remote tracking. You got to set everything up. You have to set the upstream. And so it gives you a command. It gives you a command you can copy and paste. You can rely on this every time. Okay. Git push -- set upstream origin feature button. What I typed in was the same thing, but I typed in the command that is the shorthand for it. So -u, this -u is the same thing as -- set upstream. So -u for upstream. And I typed in u origin, the name of the branch. So this branch is feature button. Both of these will work. You can simply, when you type in git push, it's gonna give you this. It's only gonna give you this the very first time you push this thing. After you push it, it'll never give you this again, and you never have to type in this whole thing again. You only have to type in git push after this. It just has to initially get everything set up. So I'll copy and paste that. So it gives it to you out of the box, and that's helpful. So now that's in GitHub. Both branches have now been pushed to GitHub, and we can actually go see that both things are in fact in GitHub now. Let's go to, and close all these. We can see that, look at this. There's a feature title here and there's a feature button, and they have different information in them. So I could, before I show you how to merge these in, we're gonna talk about PRs so that we can talk about them all together. But yeah, we've right now, both developers have done different things, okay? They've created their code in their own branches of history. How does that all get resolved now? How does that all get back into the main history of the code base? That's what we're about to talk about. So let's go into PRs. That was above this. No fetching and pulling. Pull request, okay? That's where PRs come in, all right? Pull request. A pull request allows a branch to be reviewed by others, to be reviewed by other people with the intent of merging this branch into the main branch. And I actually should change that. That is not the intent. The intent is not to merge it into the main branch. It is to merge it into any branch that you want. So all it does is so it's pull request. It's a bad name. It's not a good descriptive name. GitLab, I think, calls it a merge request because it makes a little bit more sense. They're requesting to, like, people are requesting to merge one branch into another. And this is a peer review process. So people also call PRs peer review. Sometimes they refer to it as that, but that's a full pull request. Excuse me, I'm sorry. And it is called different things in different platforms. But what it is it's asking to merge this code in, but I need some verification first. I want someone to double check the work that I've done and confirm that this is okay before it gets merged in. All right, and so all it is just a manual check process before we do the things that we've learned. We learned how to merge. I'll show you how we're gonna do that. But let's see a PR in action. The way that you create a PR is really nice. You can do it from the GitHub CLI, but I'm not gonna do that because everyone's not using it. All you gotta do is go to this pull request tab, and someone already created one yesterday, and I can actually see that that Alistair has already created a pull request. They have said, hey, I have some changes that I would like to merge into a certain branch. I want you to take a look at them. So developer one, the person who was changing the title, okay, we would go into pull request and we could go down to create a new pull request. So I'm gonna create a new pull request. All right, I'm developer one and my code is ready to go. And what I'll do is I'll go in here and I'll say, hey, I want to compare feature branch title I want to compare it to main. I'm creating this pull request with the intent of merging feature branch title into the main branch. Okay. And what it'll do is it'll set it up. It'll set up a space for this to be reviewed. It'll show you exactly what changed. It'll give you a diff, a git diff right here. It gives you a diff right in your face, which is helpful. And I give this a name, able to merge, simply create a pull request. I give it a name, say, add a web title. Down here, your company, your team will create the rules for what you put down here. Some people put a description about what was done. And, I'm just gonna type in blah, 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 not super important. You can add reviewers, so you can add specific members of your team to review this. You can assign it to certain people to take ownership of. You can give it labels, a bunch of other stuff for tracking purposes. That's all great and dandy, but we create the pull request. Don't forget to link a work item. Yeah, and so usually you would link an issue. So if you're using this properly, we don't need to talk about issues in depth, but often there is for GitHub at least, there is an issue tracker here. So people input issues and you do work against those issues. And so you can link the work that you've done to an issue itself. That helps when you're contributing to open source. But right now, not a big deal for us. When we get to contributing to open source in a few minutes, you should remember that. And so this pull request is now created and it sits here. All it does is just sits and it waits for someone to review it. So maybe I'm developer number 3 on the team. All right, and I come in and I go in here and I say, all right, let me go look at this pull request. I want to take a look at what developer number 1 has done. I'll look at it. I'll look at what they're supposed to do. I'll look at the issue to make sure what they've done is right. And I'll look at it and I'll say, I'll judge their code. I'll look to pick it apart. I'm joking. No, some people do that. But I'm looking to make sure it is, often the things that you want to check when you're looking for this is spelling mistakes. You want to make sure, is the code right? Does the code work? So you should, one of the reasons why I've heard it might be called a pull request is because I am requesting that you not only look at this code, but that you pull this code down to your local computer and you run it. Okay, so that is often something that's part of the process is, hey, this branch is here. I'm gonna download this branch. I'm gonna ensure that it runs. And I'm gonna look through your code. I'm gonna do my best to make sure your logic is sound, that this code is maintainable for our team at least. And I'm gonna look for, ways to improve it, but I'm not gonna spend all my time, you did the work. I just wanna be the last check to make sure this makes sense, okay? And, I say, cool, this is nice. I'm gonna review it. I'm gonna approve it. I could request some changes or whatever, but I'm just gonna say looks good. A lot of people do the LGTM, looks good to me. And because this is me, it won't let me approve it because I'm the person who put this in. But imagine I was another developer, I would approve it. And when I approve it, it'll let me know that, hey, this thing has now been approved. And when you're ready, you can go ahead and you can merge this pull request in from here. What is merging this pull request? Remember, I checked that this could, from feature title, I checked this against main. And I'm comparing those two, the differences between those two, and I'm gonna try to merge those things in. So I'm gonna go ahead and I'm gonna merge this pull request and confirm the merge. So you don't have to do it manually yourself. You don't have to do it manually. If there are issues, you will have to resolve them, okay? You will absolutely have to resolve them, but it kind of just works. So that worked. So developer 1 has done their job. With the help of developer 3 confirmed that this PR is good, and developer 1 has done their duty, okay? So maybe they finished in a day. Developer 2 on the other hand, all right? Developer 2, who is working on the button feature, says, cool, I'm working. It's day 2 or 3 now. I've gotten it working. I've implemented everything that I need to implement. And so now I'm ready to do the same thing, okay? So I've already pushed it. I'm good to go. And oftentimes it's up to you to kind of make these changes and things as well. But I might also go in as developer 2 and I might say, all right, I'm on the feature button branch, so I'm gonna make a whole new PR, okay? And I'm gonna go in here and I'm gonna say, I'm gonna do the same thing, add a button, even though button spelled wrong. And I'm gonna say blah, blah. I'm gonna explain what I did here. Maybe that's what you wanna do. and I am going to create the pull request. All right. This has no conflicts with the base branch. I'm now going to do feature button. What's up, Deaf and Optimist? Welcome. I'm the feature of education. Get with it. I appreciate the kind words. Thank you so much. I do appreciate it. Okay, so now I'm gonna go do this. And actually, I should have made some different changes because this is actually gonna work fine, I think. But I should have made some changes that would cause a conflict. But I would attempt now to go ahead and merge this thing in. So I might take a look at it, and I might want to merge the pull request. This is going to be fine. It's actually going to work. And what's going to happen is, if I go look at my code.txt, it's going to have both things in it. All right. Here's where Git gets weird. That worked, and there were no issues because of the types of changes that I made. But what should have happened in a less simple example, what happened here is this is what you should make sure happens. And so you don't. Okay, let me say how to say this without I'm trying not to press my ideas about a proper Git workflow, but I'm of the belief that that'll work all day. If it can be merged in, things can be merged in properly, no problem. This is why I'm personally do not use merging. Yes, PRs are for merging, but if I have a say, I require that you do this first to resolve any conflicts. I require that you get those things. Because right now, there's actually a fairly large separation between the two branches. And my feature branch does not have what I would need. We'll talk about rebasing tomorrow. We'll also talk about those workflows for merging. So this actually works fine. And so our master branch is now updated with both of those changes. Both people have contributed what they needed to contribute to the main code base. And now the histories are actually combined. So if we go back and look, let me check out main again. And we do a git log. Notice the order of, first exciting thing. First exciting thing is that one, take a look at this git log. This git log does not have, it starts at the very top. It does not have what I would expect it to have. It does not have anything about a button. It doesn't have anything about a title. Why not? Did you see my PR earlier? Yes, we did see your PR. We're actually gonna merge it in a second. I was actually gonna merge it last after all the changes that I made. Ref log, yeah, you're right. You can look at the ref log if you needed to, ref log, great. But the issue right now is that those merges happened. Where did those merges happen at? Those merges happened in GitHub. They happened at a different location, okay? So if we want those changes, what do we have to do? We have to git pull. That will fetch everything and merge it in and give us everything that we need, okay? So now if we do a git log, take a look at this. It says, there's a merge pull request too. So web title was added, then button was added in that order. Web title, then button. Great, that's helpful. That's very helpful. But take a look at this now. Let's take a look at Alistair, or maybe it's just Alistair. Let's take a look at the pull request here. We did not change. That's amazing. I didn't take a look at it, but that's very good. I see. That's look at that. Absolutely, my name is Aaron, and did you know that you can subscribe for free using Prime? That's dope. That's amazing. Now this will cause conflicts. Okay, this is great. I like this. So here's the problem. If we were to review these changes and we were to approve them, okay, so this is now dev number 4. Dev number 4 has made even new changes. Thank you so much, G-Dog. I appreciate it. Thank you so much for the Twitch Prime sub. I have now approve that to be merged in, but take a look at what it says. It says, hey, you know, I want to help you out, but I cannot. This branch has conflicts that must be resolved. So I could use the web editor or the command line. Can I actually pull this? Oh yeah, I can. So I'm actually going to do it I'm actually going to do it right now. I'm gonna pull the way that I would resolve this as developer number 4. I'm going to now check out this brand new branch. So I'm actually going to check out the patch here, okay? And when I check out this patch, when I check out the patch, I'm going to check out master. I'm going to go back to the master branch. And then I'm going to try to merge this in. So what was it called? So I'm gonna try to do a git merge and the patch that they've created, okay? Whoops. Patch, main, git merge, already up to date. Wait. What's happening here, actually? What are we on? It's patch 1. What does the code look like here? Hold on, this is not the, oh, wait. Actually, I don't know what this is. Never mind. I try to check out master instead of main. Oh, yeah. Okay. There we go. But I actually don't know. I actually don't think this works the same way because this is check out main. Oh, no FF. What is merge no FF? Oh, git pull. Oh, never mind. I have to pull the patch. Git checkout. Let me actually do what they say because so the reason why this is a little bit different is 1, they're doing it through the patch. 2, because this push was actually not from my repository. The branch that was created is not a branch that is mine. Okay, so let me go ahead and do that real quick. So let's do this. Already exists, and let's pull it. All right, there we go. So now it's gonna give us what we need to do, and now we can solve our problem right here, okay? And so I like both of these. I'm gonna accept both changes, okay? I want them both because I love this in here. So now, not only does our website have the title, not only does it have the button, it now has this amazing ASCII art of my name and reminding you that you should subscribe with a free Prime sub. I love it. Amazing. We've made an amazing application, and so we save this file now. Now what do? We run through our same setup. We've never done this pipeline with VS Code. It gives it to you already. It gives you an automatic merge message, which is very helpful. So if you want, you can just click the check. I mean, whoops, empty commit. You got to click the plus first. Click the plus to stage it. Click the check. They already filled it in for you. Why do you even need to do anything else? So you do that. Great. So you merge it, and then now you can push. So that's one way to do it. That is one way to do it. And now I probably have to force push. Okay, no, I don't have to force push. That wasn't a rebase. And now it's actually updated. It's actually taking place now, and I don't have to do anything else, which is helpful. So this is all done. See, like it's all done now. It doesn't even give me the option to merge anymore because it's all done. It sees that. If this was, there's other ways for this to work as well. Also, I could have instead merged in master I could have instead merged the changes from master into this development branch. I could have merged them into this branch here, and then the PR still could have gone through because it could then successfully merge because it's already been done. That doubles it up. But you know, that is helpful. So we just now merged a bunch of pipelines together. So we actually had, you know, and so this is actually what happened when we first created this dev 4, which was the feature ASCII art. Let's call this feature ASCII. This actually was over here, and there was a new thing put here. and it got merged in after all this stuff. So what happened is now this gets merged in over here. And now, even though all these different branches happened all around here, the main branch has, like here, the main branch actually has all of the changes that happened in this whole thing. It's got them all. Okay, it's flowed together, and it's all been kind of merged back together. It's all been you know, combined back down into a point where we were able to work on different paths of the code and then combine them all together later. So that is you know, a little bit of fun with the PRs. So pull request just is a request to merge. It's a merge request. It's say, hey, I want someone to look at this so that I can merge it in with the intent of merging it in. Real quick, the last two things that we're gonna talk about today are forking and contributing to open source. And so exactly what Alistair just did was contribute to open source. And I'm gonna show you how to do exactly, yes, another successful contribution. 100%, that is what just happened. You can do this as well. So first, forking. All forking is making a copy of an entire repository in your account, basically. So we've been cloning repositories. Imagine cloning this, but cloning it into your account. Okay, so instead of you just taking the history of this code, the entire history, all the files and things, but being linked back to the main one, you are cloning it into your own account. So right now, what you could do, let's do this with CLI, the GitHub CLI. Let's do it with the GitHub CLI. Let's say anything that is public, anything that's public, and maybe so anything that's public, that you have access to, you can fork it. All right. So when I click this fork button right now, this CLI is in the GitHub account, the GitHub CLI account, and the repo is called CLI. I'm gonna fork it. It's going to make a full copy of this. And now instead of CLI, it is Mastermind IO CLI. So I created a new repo in my own account that's based off of this entire repository and its complete history, but it's in my account. Why in the world would I want to do this? This allows you to freely modify a repo without affecting the original project. Okay. So even still, because of authentication, you know, even if you were to clone it directly and try to modify it, you would be modifying the history of the actual code base, but you couldn't push that anywhere, so it wouldn't get saved anywhere else. But because it's distributed, you are actually making modifications to that thing, but it just can't get pushed anywhere. Forking allows you to do it if you want to play around with some code that was written. If you want to just mess around, you can fork it into your own repository and have full control over pushing changes to it, because it'll go to yours. Not only though can you do that, you can actually connect. You can actually link your fork to the original repository, and changes that you make in yours, you can request that the owner of the other project accepts your changes. So that's how Alistair did it in mine. He forked it, made some changes, said, hey, I like this. I actually would love for you to stick the changes that I made into the original code base, if you would. And a pull request was created, and now it is there. It's contributed to open source. So let's talk about that, contributing to open source. First, what is open source software? It's software with source code being the human readable code that you write, that anyone can inspect, modify, and enhance. So the code is freely available for you to look at, for you to modify, and for you to enhance. There's tons of free and open source software out here. The world runs on free and open source software. It's phenomenal. It's very, very exciting. And notice we said modify and enhance. All of us can contribute to open source software. That's the best thing. It's the best. Fork is like having a branch in your account. Kinda. So I do think it's okay to think about it like that right now. But it's more than just a branch in your account. It's the whole history of the project. So you still got to create your own branches. Well, maybe not. But it's like a bigger branch off of the, it creates a new history, but of the entire history of the repository. So not quite like a branch. because you can still keep yours in line with the history of that one, of the main one. But it allows you to take a completely different path. Let's say you love Node.js and you don't like the direction that they're going. You could take Node.js and you could create a fork of it. You could create a new history that's based off of the entire old history, and be able to, completely change the direction of the project. And if you wanted to, because you have a connection between the two, you could send, key features that you've created back to the other one, or you could request that they be put in there. It's pretty interesting. Worth mentioning, fork is not a subcommand of Git. It just describes a way of setting up a repository. Yes, correct. That's very good. It's not something that you do from the command line. This is it's a way of setting up this internal repository in your own account. That's again based off of someone else's, in that it takes the entire history of that thing and sets it up kind of as if you set it up, honestly, in your own account. So bridging repos. How, I've cloned this one. I've cloned the GitHub CLI just now. Not cloned, I forked it into my own account. Where did I fork it at? What? I'm closing all this. We go back in here because I did fork it. Repositories. And how do I easily see? Yeah, too many tab syndrome for sure. CLI is what it was called, right? Yeah, here we go. All right, so look at this. I still have all 3,312 commits to the main branch. I didn't do those. I didn't do any of these. All these people contributed to this thing, okay? But the whole history is here, like like I have it. So after you do that, by changing the remote for the forked branch, so you take you create a branch that you want to work on. When you change the remote for that, you can create a bridge between the forked repo and the original repo. This is helpful because with this bridge, you can get updates from the original repo as well as push updates to the repo. So let's say I'm trying to build a new tool based off of the CLI. Maybe I'm trying to make CLI number 2 and I want it to be epic. But at the same time, they're continuing development on the CLI. You set it up, you set your remote to point at these things. I can pull updates from the main repo. I can pull updates from here down into my forked repository, which is super helpful. And as I do work, as I create my own branches, I can then also push work or ask for work to be pushed into the to the origin repository. Okay. Fushnip, thank you so much for the Twitch Prime sub. Thank you so much for the love. Itemize, welcome to the channel. Thank you for the follow. Oscar, welcome as well. Sorry I did not get you all with the follow. Thank you. BJ, welcome as well. Hacksighted, good to have you. Can you just delete the Git folder and add a new remote? Yeah, you could. You don't need to delete the Git folder. You could delete the Git folder, but then you have to reinitialize it and add the proper remote. You could. You can change the remote. You can change the remote pretty easily. I'll show you how to do it. I always forget. I always have to look it up. You all always have to tell me, but I'll show you how to do it. But this is the process for contributing to open source. If you ever want to contribute to open source, so you create this is the common method. So first, you create an issue. So I'm gonna show you how this works though. But first, you create an issue. So instead of just messing around and pushing stuff, what I would do is I would say, hey, I have let's go back to CLI. I have some things that I think need to be changed about this. So I'm going to create an issue to track it. I can go in here and I can create an issue on any public repository, okay? And I say, hey, I would like for this feature to be implemented. Even if I want to do it, I would say I would love for this feature to be implemented because of this, okay? And so I create an issue for it. This allows for work to be tracked and to help people understand what in the world is here and what should be worked on or what could be worked on. and let people know what's wrong with the code base, whatever. I create an issue first. That's the first thing that you want to do. Then you say, cool, I'm asking for this thing, but I know how to fix it. I plan on implementing it myself. Then you fork the repository. We forked it into our own account. Cool. Once you fork it, you clone it to your local computer, which I'm about to do. You create a new branch. All right. Then you code. After you create your branch, the same way we just did with Dev 1, Dev 2, and Dev 3 and 4, we do our work. We go through, we build what we need to build. We resolve the issue that we created. Then you create an upstream pull request. So you create another pull request, but you create it upstream. I'm going to show you how to do that in a second. And that is the standard way of contributing to open source. You don't have to create the issue, but an issue could be created. So maybe you're like, hey, I want to try something out. You can go through your favorite project and you can look through and you can read through and you can say, okay, you know what? I think that, I can solve this. GitHub issue list sort flag. I think I can solve that. I've read it. I understand what the problem is. I think that I can implement this or solve it, and I would go off and do that. So you don't have to create an issue, and you should look through the issues to make sure there's not a duplicate issue that can be very annoying for open source projects. So just be wary of that. But we took this. I'm gonna go back to my repositories. I'm gonna go into CLI. I'm gonna clone this, okay? Take it, and I'm gonna clone this right here. Git clone, paste in the URL. All right, so it's gonna clone the one from my account. Open it up really quick so you can see it in VS Code. And the first thing, so an issue. So let me go back over here and let's say we're going to issues real quick. Maybe there's a bug here. Avoid persisting the choice. I don't know what this is. And I say, great, I can solve this problem. And I say, cool. First thing I want to do is I want to create a branch just like normal. That's the process that I need to follow, or that I should follow. That's good Git practices. And I might say, cool, let's go ahead and create a branch. Git checkout -b. And I might want to use something, relatable. This issue number is 3039. So I might want to say, Git checkout -b feature. You can call it whatever you want, but I might do this feature -issue -3039. Though often there often will be a document that explains how they would like you to name branches and the process they would like you to take when contributing to open source. But we're just going off of some base stuff. And so I create a new whoops, that didn't work because I need to be in the directory, which is here. And I'll check that out. So brand new branch is created. I'm now on, I should be on this branch now, and I'm not sure why that's not updated down here, but sure. I feel like that should be updated. Okay, so I say, cool, I want to solve this problem. So I'm gonna go ahead and, because I'm in the wrong directory. That is why, hold on. Okay, this is one of the problems of remote development. So cool, we got this. I'm gonna go ahead and now I'm going to modify some code. So client.go, I'm gonna modify it. We got some stuff here, and you say I'm gonna solve it. And I don't like I don't know. I'm gonna change this struct here, and I'm also gonna give it a new thing, which is gonna be int. Okay, and once we have that in here, now I need to go down and I need to use I'm just typing random code in here. This vid is equal to choo. I'm literally thinking the most random stuff I can think of. Whatever. We made some changes in here, and I think that these changes are the ones that have solved this problem. I've added something to our struct up here, which is int32, and you know, I've added this variable called choo-choo, which I've never used, that has a dumb name. Whatever, all good. And I say, cool, I think this is good. You know, how can I check out what I did? Let's check the diff here. You know, I can look at it here to confirm, but how do we do it from the command line? You know, make sure you are getting some practice in. So I do a git status, and maybe I'll do a git diff first. Maybe I'll make sure that I'm modifying what I want to modify. So take a look at that. The git diff, I added this line here, and I added this line here, and I say, cool, that's exactly what I wanted to do. Exactly. All right, and I do a git status. I do a git add. Actually, let me do git status again because I don't know what file that is. I'm gonna add API client go. Nope, client.go. Do a git status again, make sure we're good to go. Git commit -m. Again, be more descriptive than this, but I'm gonna say resolved the thing. Can't type, but it's okay. And then now I'm going to git push, okay? And it's gonna give me this little origin master to set up my remote tracking here. And I'm gonna push it. Where did this push to? This pushed to our cloned repository, okay? So now if I go back into our repositories and I look at the CLI here, it says, hey, you know, compare and pull requests. I push these things here. I can now compare and I can pull, I can create a pull request. By default, you don't have to do anything special to be able to contribute to open source. You don't have to set up any special bridges or anything like that. You do if you want to pull changes. So you should set that up. I can show you how to set up the remotes, or I can give you a guide for it. But take a look at the top here when we're creating this pull request. The base repository is not ours. It's not mastermind.io/CLI. It is CLI/CLI. And we want to combine this into the main trunk. Okay. And then over here, it's selecting the branch that we care about here, and we can say, hey, resolve the thing, you know, issue number, how do I see, issue number 3309 or whatever, and we can, you know, put our stuff here, and we can create this pull request. Okay, I'm going to, I don't want to, we did this last time for a smaller project, and I submitted it, and the person actually checked out the stream, which was cool. But I don't want to. They already have a number of things that they're dealing with, and I don't want to. They have actually have 14 pull requests. Now we're gonna do it. YOLO. Delete this. Comma teaching how to contribute to open source. Okay, we did a thing. All right. Yes, base trunk. That's their default branch. So if we actually look at the new tab, that is what they call their base branch. They actually call it trunk. Okay, so they do something called trunk-based development. Couldn't you close the PR? Yeah, I can close the PR after creating it. You're right. You could. I could do that. Or I could make them close it for. Nah, I'm joking. Yeah, I could close it. But they call theirs trunk. That's all it is. If it was called main, it would say main instead over here for us. But they call theirs trunk. And so I'll create a pull request. And now they've now received notification, and now this pull request is now available for someone to take a look at. Right now it's doing a build. This build will in fact fail for sure, because in Go, you cannot create a variable without using it, for one. And I also created, you know, extra stuff in that struct, and, you know, it's still waiting for a review. It's running a bunch of automated checks right now to kind of test the validity of this code, see if I broke anything, which I did. So these tests should fail if they've written any kind of decent tests. And it won't build. It won't build at all because Go won't compile with the changes that I made. And then someone can come in and make some comments and ask for updates, and they could choose to accept this or not accept it. But we have now contributed to open source. But I'm gonna close this. What's the where can I close this? I think you can go to the bottom and close it without making a change. Let's see. And so you can see my build fail. That's what the X is for. Good. Close this pull request. Delete branch. We were learning. Okay, and so now I closed it, but that is how you contribute to open source. But you might be saying, oh, well, I don't know how to code all that well yet. Well, how would you contribute to open source? One of the best ways to contribute to open source is looking through documentation and improving documentation. You don't have to solve the toughest coding challenges. Every repo has might have some installation instructions or README with some information. And, you can start saying, hey, maybe like you go through it and maybe you see a command that's out of date, or you see that a command or some instructions that are there. Maybe they assume you have something there and you say, hey, I think it would actually help people if you put in here that you also need this extra tool that might not be commonly installed or something like that. It can help you. You can contribute in that manner. You don't always have to go solve the world's problems. Documentation is one of the best ways to get involved with contributing to open source if you'd like to. Also, you can start by helping review pull requests. If you're confident in your ability to start reading code, actually, if you're learning how to code at all, I highly recommend you finding a repo that's using the language and frameworks that you care about and start to look through those PRs, because you don't have any familiarity with the project. So it's going to take a lot for you to understand what's going on. And the act of looking and going through and reading code and trying to follow the logic is very beneficial when you are learning. It's super beneficial. So I highly recommend. That's a good way as well to kind of see different codes, see things people are doing, and it helps you learn. People also put some really good comments on why or why not something should be accepted or why it's beneficial. Those things are beneficial as well. You can learn a lot from all of that. You can learn a lot from it, for sure. But yeah, that's how you would contribute to an open source project. And so one thing that we are going to do, I hope to have it up and running by the start of the level 2 boot camps coming up soon, is a small number, probably 3 actual usable repositories for some apps, some little things we've been building, that you all can begin to contribute to if you're looking for something to put on your resume. There might be some projects that should be accessible for for being able to contribute to. And it might give you, if you're looking for something to do, a project to work on, something that's verifiable, we'll give you some stuff that's complete, but not super complete, that you can contribute to, that hopefully people will actually use. But that's it for today. What are the tangible takeaways? The tangible takeaways are everything that's on today's topics, are that you can authenticate and authorize your actions on GitHub using SSH or HTTPS. We talk about the differences between those and how you can choose the right URL or connection string to be able to do that. We also learned about GitHub CLI and how you can use that as well to authorize and set up stuff with GitHub. It's pretty cool. You should check out GitHub CLI. We talked about SSH keys and how you create one and how you add them to your account so that you can use these SSH key pairs to be able to authenticate. It's super helpful because a lot of people use those. For authentication. We learned about how do you see changes that have been made to the repository? How do you track those things? Git log is how you can see a history of commits. You can see the history of commits, when they happened, who they happened by, the unique ID for them, the message that was created when that happened. And we learned about git diff, so you can see exactly what changed in each file. That's super helpful. Fetching and pulling, we learned about the differences. Fetching grabs the updates. Pulling grabs the updates and it merges them into the current working directory. The first fetching allows you to get updates without having to deal with any conflicts, but pulling has you run into a few conflicts. We learned about pull requests, where you request for people to confirm the validity of your code to allow it to be merged into another branch. Merging, when we just fold 2 histories on top of each other and we combine 2 histories. Forking, being able to take an entire repository in its history and set it up basically in your own account. And contributing to open source, how you use forking and how you use the process of creating a branch and making changes and using the pull request process, the PR process, to be able to contribute to other people's code is can be super helpful. Yeah, that's everything for today. Hopefully you got a little bit out of today. How do they name issue numbers? By the person who creates it is, sets that thing up. The person who creates it, so it might get tagged an automatic issue number. Yeah, they'll usually tell you. There's usually like a contributing. So in here, there's probably a contribution.md somewhere, maybe not. There's usually a markdown file for contributions in here somewhere, or something that will tell us how to do it. If they have a way of doing it. But yeah. MB, is that right? Absolutely, take a look at yesterday's. All good. It's only 3 parts, so you should be able to catch up quickly for sure. Oh, yep, RWX Rob is the person. Absolutely, Propagation Nation. Thanks for coming through. Could do this, absolutely. What's the name of the other guy? Yeah, that's RWX Rob. And she's good. She is good. I'm about to go check on her right now. We're still on baby watch, but I think she's getting to the point where she's like, all right, come on, baby. It's time to be done here. But she's good. I'm gonna go see if she needs anything right now. That's why I got to get off. Again, if you're interested in learning, so tomorrow, real quick, what we'll be doing is we'll be learning about we'll be doing cherry picking. We'll be talking about Git workflows. We'll be talking about reverting. How do you get out of messes is really what we're really going to talk about. Conflict resolution we talk about today, but we'll talk about that deeper tomorrow. Rebasing, reverting, resetting, how you figure that stuff out, stashing as well. Basically, tomorrow's going to be, excuse my language, but it's a website. Oh shit, Git. It is like Git really is it's an oh shit tool. It's like I get myself into a mess. You can get into huge messes, and tomorrow will teach you everything you need to know. Well, not everything you need to know, but it'll teach you some strategies for getting out of your messes. Cool. I appreciate that. Thank you so much. Thank you for having us in your prayers. Yeah, it's still confusing. It really is. It's almost always confusing. I'm sure that tomorrow we'll run into something and I'll be like, wait, how do we get here? Wait, let me, what do I do now? Guaranteed. So cool. That's it for tonight. On Thursday, Friday, and Saturday, we're doing the 3-part Linux series. So if you're interested in learning Linux and doing a deep dive and learning how to deal with the command line and figure out all that stuff, we'll be doing that on Thursday, Friday, and Saturday. But we need to head over and we need to raid somebody. Who are we going to go say hello to? Oh, absolutely. We are 100% going to see the Primogen. We haven't been over there in a very long time. So that's who we will say hello to. Another Only Devs team member. The Primogen. Cool. We're out of here. Thank you so much for coming through and spending some time with me. Hopefully you got something out of today. Tomorrow we'll kind of wrap it all up and we'll put a little bow on it. We'll have some conversations. Tomorrow we'll probably answer some questions as well. We'll take some time to ask your questions about the industry and what you want to learn next and all those other things. So yeah, I will see you tomorrow. Dope, MB. I look forward to seeing you tomorrow. Go say hello to the Primogen, and I will see you all tomorrow. We gotta wait for one more person to come with us on the raid because there's 68. There we go, 69. We're leaving. Bye.